Well, hello everybody. Welcome to SkyTour LiveStream for August 22nd, 2020. You know me. You also know Daryl, who's here. I think he's right about there. Daryl, you here somewhere?
Somewhere.
There he is. He's right in there. Yeah, he's in here somewhere, yes. We are, of course, having some preliminary talk here as we start going through what we're going to do tonight. And tonight I figured we would take a journey through Cygnus again, Cygnus the Swan, but also adjoining constellations nearby, because we want to look at some of these guys right here that you see on the screen. Okay, this guy right here is a carbon star. These are the stars that are absolutely phenomenally colored. They're blood red. I have no idea, why they're, I know why they're so blood red, but I have no idea why they don't get the coverage that they should in the press. They are absolutely stunning. There's only one star of this nature that's actually has an official name, and that's called, as Daryl said earlier, which you didn't hear because we weren't on live yet, it's called the Garnet Star, Garnet, the Garnet Star, because it's so blood red. And Daryl, do you remember the constellation that the Garnet Star is in?
You would ask me that, wouldn't you?
Yeah, well, you know what? Well, I don't remember
I'd
either.
have to look it up. I don't remember offhand.
All right, well, if you got a moment to do that while you're doing that, I'm just trying to get a few things organized for everybody here.
Sure.
I've got everybody listening to me here. I got a wonderful itinerary, I think, tonight planned for us. We're going to be going to a few nebulae, but we're also going to be looking at the Garnet Star. The Garnet type stars. These blood red stars that are just so incredible. If you think about it,
Herschel's Garnet Star is in the constellation Cepheus, so that's just north. That's just north of Cygnus.
That's what I thought. See, and I was looking for a Cepheus, a Garnet stars actually, because I want to look at that, and we will look at this famous star, because I was actually hunting through Cepheus a little earlier. And I actually did. There's only one. Is it Delta Cephi?
Mu Cephei.
Mu Cephei, huh? Okay.
Also known as Herschel's Garnet Star.
Okay.
There's also Hind's Christmas Star. I don't remember where it is either.
Okay. Interesting, because the one piece of data. The one piece of data for the one star in Cepheus, which is here, which has to be that one, is broken. So I don't have that data. I don't have the declination. But I'm sure we can find it, no problem.
I can copy you the RA and...
you know what? You can actually just state the RA. Okay. You can just state the RA. First of all, let me get us back to our daily view for those who, well, the ones that are here are people that have been here before, but I'll wait for the room to fill up a little bit more before going through the overview of what we've got going on here. But I just want to say hi to Terry Groff, all right, my buddy from another mother, my brother, and he's down in Dallas, Texas. And I visited him down there when we did a show, and Tara's here, and Marianne Robb is here. Two of the most helpful people for SkyTour LiveStream West right there. Marianne and then Tara. And then we have Governor is here with us. Trish D is here. And we also have, let's see, I think, and Devin7 is here. He retracted his message, but that's okay, Devin. It's nice to see you here. We have Craig MK3. Nice to see you. Thanks for joining us out here. We're going to be checking out some of these stars. You can actually see some of these stars when we get going here very clearly, and I will make those obvious. I'm just waiting for Daryl to give me coordinates here for us to...
Oh, sorry. Did you want me to just say them?
Yeah, you can just say them, because I'm just going to put them right in. Okay, let's
21 hours, 43 minutes, 30.46 seconds.
Okay.
Right ascension.
That's what you got, right? And now I've got
excuse me, declination.
Yeah, go ahead.
Plus 58 degrees, 46 minutes, 48.2 seconds.
Okay, 48.2. Okay, those coordinates he's giving us right now are the coordinates of this particular star that we want to go see. And I'm going to hope that the dome isn't in the way of this. I don't think it is. I purposely set it so it wasn't. You saw the stars just disappear right now. That was because we're actually heading out to this area. This is, you can see over in the observatory cam down here in the lower right, you can see the telescope is pointing perfectly fine. And it's going to bring us to a star probably doing precision pointing. So I expect to see that there might be a star that we're going to first, which we just did. You can see some stars whipping through here. All right, and then we're going to align with our object star that we want to see. And let's see, we are, that's kind of interesting. It's actually, it's picked the Garnet star right there. That's pretty impressive right there, Daryl. Look at that.
Yeah.
The Garnet star, that's the one we want to see. The Garnet star is really fascinating. And I'll tell you why. First of all, let's bring it up into the view so we can see it a little more. Okay. You were getting me the coordinates for the Garnet star. Thank you. I forgot about that for one split second. Now, you look at it, it looks kind of orange, but let's just take a photo and take a look at it, all right? I think that will show you a little bit more. We're going to do 20 seconds. Okay, the camera is over here. The camera controls 20 seconds at 6400 ISO. So that should be good enough. So we're going to do a quick 20-second shot. And we're off and running. And then we'll come over here. This is an earlier star that I took an image of. That was a carbon star in the constellation Cygnus. I will explain what carbon stars are too, by the way. Yeah, Trish D, I actually made a comment about that asteroid arriving in November because people like, wow, look at that. People like Corey Good are out there fanning the flames of fear. You know, at least what I can see is he did. And the asteroid that's arriving in November is a whole 6 feet across. Okay, and even if it struck us dead on, none of it would reach the Earth's surface. All right, so we get hit by asteroids that size all the time. In fact, it should be called a meteor. It's not even really. It's a very, very small asteroid, if that, or a larger meteorite, or meteor rather. So it's really not that. It's really not that bad. And in fact, Sunday's show on SkyTour Radio, we're going to talk about impacts on the Earth, and we're going to actually do some calculations. I have them already done for you, and we'll talk about how impacts can affect the Earth and how seemingly large objects don't have any permanent effect on the Earth. Of course, the very large objects like the Chicxulub impactor in 65 million years ago that resulted in the ending of the dinosaurs era, those types of impacts will change life on Earth. But they don't change the Earth itself. The Earth continues, shrugs these off like you can't believe. Life suffers greatly and changes the course of life on the planet, but the planet is not affected. Its orbit isn't affected in any way, for instance. So, but I will talk about it Sunday night as well. And I'll talk about it more tonight if you have questions, for sure. Yeah.
There was another one, that one that passed like within 2,000 miles of Earth, they said last week, I think.
1,830 miles, actually, and we're talking about that Sunday, too. We're talking about that tomorrow night.
Yeah, I read somewhere that one was like the size of a pickup truck, and just like the one you mentioned, you know, that's nothing on the big scale of things.
No, we get hit by asteroids of that size. The Chelyabinsk meteor, that they call it, that entered the Earth's atmosphere was much bigger than that. It was about 20 feet across, and it blew out security doors and windows. The way it came into the Earth's atmosphere, it exploded, and the shock wave from that was tremendous, you know. So yeah. So this is what's called the Garnet Star, and it's in the constellation of Cepheus, it's actually one of very few of these types of stars in the constellation of Cepheus, and Cepheus is just north of Cygnus. Cygnus has 6 to 8 of these, I believe, and Cepheus has 1, which is kind of interesting. Let's see. So this is a very cool carbon star. You can see, if we look at it closely, you can see that it really differs in color from all the stars around it. Okay, and that's because these stars have a particular chemical composition that makes them look very, very, very red. I mean, blood red. And even though they'd be bright in the sky to your eye, if you were near them, you would definitely notice a very, very unearthly red color. And this is because the stars that are in this position, the stars that have this particular chemical composition, are actually stars that have stopped fusing hydrogen into helium for quite a long time, and they're now entering a branch of their evolution that takes them off the location on the diagram we call the Hertzsprung-Russell diagram, which shows stars in a snaky line, right? And the stars in a snaky line will actually be fusing hydrogen into helium normally. That's what they do. And but when we look at the stars that are creating this red stuff here, this red glow, this red color, we're actually seeing stars that are actually dredging up from their interiors a lot of carbon. It gets to the surface, and because this star has stopped fusing hydrogen into helium, it's bloated up very, very large. And because it's bloated very large, the outer layers are very far away from the core of the star. So that already makes it cooler, as in lower temperature. But as it expands like that, those outer layers can actually house molecules as well, because it's not that hot out there. And these molecules can combine under certain conditions and form dust. And because they're carbon molecules, it's going to be, of course, jet black particles when you finally start getting these things accumulating in any amount. And these jet black particles against a brighter star are going to cause the light to be reddened, and thus we see a sooty star. And that's kind of what this is, right? Because isn't that what soot is? Is carbonized carbon compounds coming off of a burned object. And so we're seeing a chemical soot in the atmosphere of the star that's causing this reddening here. And that's what this is all about here. But those are what carbon stars are all about, and I think that's pretty cool, you know. Craig, you're up in northern England, is that what you said? I can't tell. I'm not wearing my glasses, but that's okay.
Yes, he said he's in northern England.
Okay.
He saw a red object like this, he said, about midnight his time, nearly overhead from England.
Oh, okay.
I know Mars is rising at 10 or 11 p.m. now.
Yeah.
And it's quite bright, and it's getting even brighter, going to get even brighter. But it would be in the east about 10 or 11 and be overhead about sunrise.
Yeah, I think I'm wondering, is it possible, Craig, that you saw Mars?
That was my first thought.
Yeah. Yeah, Marianne, she actually took me to Meteor Crater when I was doing talks in Arizona. And, you know, if you've never been there, you should go. It's a privately owned facility, so to that end, it's kind of a tourist trap, I guess. But if you've never seen the result of a meteor impact on Earth, then, and this is a weathered one, so the bottom is filled in, so it's flat in the bottom. It's no longer a bowl. Filled in with sediments over the years, but you have to check it out. We will be talking about Meteor Crater tomorrow night as well when we go through all the different impact scenarios. We're actually going to talk about various impact scenarios And that's just the lead into the main topic tomorrow, okay? Which is going to take us down the path of possibly, carbon stars and some others. But we're going to talk about those, and we're going to talk about the formation of our solar system and how it happened and how it's possible that supernovae are responsible ultimately for the formation of our solar system. And I think that's something that you'd probably enjoy. The impact stuff is kind of cool too. Yeah, Craig says maybe it was Mars. Yeah, it's really the only really big red thing that you're going to see in the sky right now. And I mean, compared to like a star like Betelgeuse, which by the way is dimming again, or Antares, which is the eye of the Scorpion, currently on the southern horizon right now, you can see it. Compared to those, Mars is much brighter, and it's clearly got some diameter to it. When we looked at Mars, maybe we can get a chance to look at Mars tonight, Daryl. That's possible. We can just wait and see how long it takes for us to get through our carbon stars and some of these nebulae, right? I do want to do some shots of the North America Nebula as well. Let's see. What am I doing? I have one more picture that I want to show folks here.
Sorry, I was on mute.
That's okay.
Yeah, Mars. Oh, Mars won't be well up for viewing until later tonight, but it rises 10 p.m. or so, I think, depending on where you are in your time zone.
Okay.
Saw a great time lapse of image of Mars at Space Weather the other day, and showing lots of detail. The guy looked equipped to catch it, though.
Yeah.
You can see the edge of Syrtis Major, and you can see Sinus Sebaeus.
Wow.
It's a really good-looking image. See the South Polar Cap, too.
Yeah, I caught the South Polar Cap here, which is kind of interesting. Hey, Randy Harris. Yeah, see, you can still. I think there's still private tours you can take to the bottom of the crater, Randy. I mean, I talked to a guy kind of offline there, and he said that there's still a way to get to the bottom of the crater. What's interesting is there was a guy flying an airplane, and he flew into the crater, which has got to be 1,000 feet across anyway, and he brought his plane in, and he actually was circling inside the crater, lower and lower and lower, and then finally, when he went to get out, he couldn't get out. The plane couldn't climb, and it had to do with the weather in the crater versus outside. The air density was different, and he couldn't get out of the crater. It's like a antlion hill where they flick the dirt up, and the ants fall down, and they get grabbed by the jaws of the antlion. Well, the plane actually circled, and finally it did crash. And I think he actually survived, but some of the wreckage of the aircraft is actually still there today, and I took photos of it from the rim. So there's pieces of the aluminum aircraft skin down there still. So note to all of you, don't fly your plane into a meteor crater. I mean, I don't know what he was thinking. There were two of them on board, I think, and Marianne knows the story better, I think.
Would that be a case of, what do they call it, density altitude or something?
Yeah, it's actually, I think it's a case of that exactly. I think that's why he failed to make altitude. Yep. Yeah. And now, look, Marianne and Tara are talking about people falling into the crater. Yeah, if you want to go down the bottom of the accidentally trip and fall. I don't know if you've seen the edge of a meteor crater. You're gonna get stopped by some big blocks that will pulverize your face. So I don't see that as a strong possibility anymore. All right. So that's Herschel's Garnet Star. I want to try and take us now to one of the other ones I was looking at earlier. And I want to do this in Cygnus here because this is really cool. Let's see. Here's the one I want. This one is really interesting. This one is probably one of the more red ones. These carbon stars have their own nomenclature, and that nomenclature is that the carbon stars will have a designation of C for carbon and 0 through 9. So we're going to go look at a C9. Okay. So that's going to be interesting. So we'll do that. Let's see. We have to go 20 hours, 18 minutes. I'm filling in over on the left side here where my cursor is. I'm filling in the coordinates. 2018-33. And then that should be this guy, right? And then 37-26-59. 37-26-59. And these coordinates are actually confusing as they may 39. As they may appear to be, it's really not confusing because we're actually imagine that the Earth's latitude and longitude system is extended out into space. That's what we're actually looking at here. That's what we're imagining this thing, that these coordinates being extended out into space. All right. So let's see what I know that didn't really answer much for you, but I will do a discussion with you. Okay, there's Solder, which is the central star in Cygnus the Swan, and it's centering it, and then you'll see it whip away because we're going to go from there to our final destination. It's called a high precision slewing, where the telescope puts a known object in, centers it exactly, and then goes to another object that we want to see. All right. Now, I don't see our red star here, but I hope I got the coordinates right. Let's see, I got the coordinates right. Let's see. It might be here too. 37-26. Oh, it is 59. Okay, 2018-33. And 37-26-59. Okay, I was off a little bit, but no matter. Let's go see if it's going to show us. That's an earlier shot. So let's do 20 seconds at 6400 to see if it's actually in the view. It may not be, but we'll find out. I did get the coordinates wrong a little bit. What can I say? Okay, 20 seconds coming up. And kaboom. Yeah, I didn't get it right. Sorry. I don't know. I don't know how that happened. Oh, unless... actually, some of these stars are actually quite dim. Yeah, this one's magnitude varies from 8.8 to 13.2. So, this could be that faint star right there in the middle. Maybe that guy. So, let's go do something that's a little bit more exciting, Daryl. Okay.
Yes, sir.
We'll do that. Okay, this one. Let's try this next one. Okay, we'll try this. Alright. We'll head to this guy. So I'm actually getting the coordinates, and we're going to put them in over here. Let's see where we are. 2019-36. And 47. 53. 39. And go to. And the stars will race away. Boom, there they go. And again, we're doing the high precision pointing, basically. So it's going to bring a star up to the center that we're trying to use as a model star for our pointing, and then we will go to that location. And this star is this star. Where is this? Okay, we're on Deneb right now. This is the brightest star in here. And we're going to get off the Garnet star because that's not where we're going. Okay, and this one is just to the right of Deneb here. Okay, and this is our planetarium view, but I have a feeling that the star we want to see is this guy right here. So I'm going to move our, I think there's going to be a really beautiful photo here. 1 second. I'm going to move our beautiful little garnet looking star, our carbon star, into the view here. A little bit more, a little bit down.
One on the right looks kind of red.
This one over here?
Oh, no. The pair there on the left.
Yeah, this is the one I'm talking about.
Yep.
Yeah, I think that's our carbon star. So we're going to go drop this down. All right. And we give our guide star time to be acquired. And we do that because the telescope requires 11 seconds exactly to lock on. And I believe it's locked on by now. We'll just do 20 seconds at 6400 for now. Oops, that's the wrong one. Okay, 20 seconds at 6400. Here we go. Hey, DW, how you doing? Amos Cardoza's here. How you doing? Nice to see you. Thank you for joining us tonight. Okay, let's see what this looks like after 20 seconds. And boom. Look at that. Here it is. That is a beautiful carbon star paired up with a beautiful, look at that. Wow.
That's red.
Yeah, it's really beautiful. Really, really beautiful. Wow. Nice. I'm going to do another exposure, but I'm going to actually go a little bit longer or a little higher. Let's go up 8,000 and let's go do 30 seconds at 8,000 here. So now we'll see what that one looks like. I want to try and capture a little bit more of the red. How's it going, Amos? Looks like a police car light bar, Marianne says. I wonder why she would say that. Maybe because she is a police officer.
Bad boys, bad boys.
What you gonna do? What you gonna do when they come
for you?
Yeah, come for you. Yeah, I used to know that whole song. I used to sing it just because it was annoying. I had a lot of state police friends. I would just sing it, and they're like, "Yay!" Roll their eyes. I stopped. Didn't take long. So there we go. That's a beautiful pair, huh? Look at that.
It is. It's very nice.
And you know something? You can't see this without a telescope. This carbon star. I mean, look at that. That red. I mean, yes, they do look like police lights. It looks like, you know, Marianne on a traffic stop. But this carbon star, you have to keep in mind, these are stars that are at a particular point in their evolution. And that point of their evolution is called the asymptotic giant branch. It's where they have actually turned off that from that hydrogen fusion path that they were on, and have gone north of it a little bit, and they start to expand in size. Okay, the vertical axis is luminosity, which is intrinsic brightness, and so that goes way up, and so the star has to go way up. And the bottom one has to do with temperature. And as the star cools, okay, as it expands, that star it gets cooler, so it goes this way. It goes toward the cooler end and goes at higher luminosity. So it ends up in the upper right corner, but then it ends up contracting and coming down, and it ends up in this space called the asymptotic giant branch. And when it's in that location, that's when the carbon atoms can get dredged up, when it's this big giant red giant star. It's a massive star we're looking at, okay, but just far away. And
are you talking the Hertzsprung-Russell diagram?
yes.
Okay.
Yeah, and so when the carbon gets dredged up, it ends up finding its way to the surface, where it forms the molecules I talked about, carbon, and more. And the more molecules that combine with each other, when the star is so distended that the outer atmosphere is literally tenuous at best, and is weakly held to the star. So this shell of the outer atmosphere of the star can be littered with these molecules and particulates. In fact, this dust and soot I was telling you about. And you know what happens when there's smoke in the air from a forest fire. Those of you in California know that well. Those of you in Arizona know that better right now. And that is that you get a lot of smoke in the air. And that smoke will tend to redden the midday sun. When you have a lot of smoke in the air, the sun is going to look very red. And if you have then when the sun goes to set, you might just have this disc of orange that you can stare right at with your eyes and not feel like it's too bright. And that's because of the reddening caused by all of the smoke particles in the air. And so in the same way, the outer atmosphere of a star is polluted similarly by the carbon atoms that are in its atmosphere, dredged up from deep within, and it'll tend to make the star look redder as well. It's just beautiful. Carbon stars are a mystery, but they're a beautiful mystery. We understand them, but we, I just think they just look mystical, I should say. Yeah. And Daryl, you put up a link to the Hertzsprung-Russell diagram, didn't you?
I did, 2 of them. One is
Very
the main
good.
article. The second one is an illustration showing the diagram itself.
Awesome. Thank you. That's very, very good.
I think the asymptotic giant branch is the one going off to the upper right, correct?
Yeah.
Yeah.
Yep. That's correct. All right.
Do know, as I said, the first link is to the main article. The second link is to the image of the diagram itself.
Okay, I'm gonna try to find something here for you. Okay, just a sec. I'm looking for something, folks, so give me a moment. I actually tried to have this ready before, and I forgot to do it. My mistake.
Marianne, I watched the moon setting last night here in Colorado, and it was just blood red. Really eerie looking, and sunrises and sunsets have been really red here as well. The sun had a lot of color to it all day long today.
Are you getting soot from the fires in Arizona?
No, we have our own fires here in Colorado.
Oh, okay.
Plus, they're saying all the smoke from the fires in California may be coming this way too.
Yeah.
it's been really smoky and hazy here.
Yeah, I believe it.
Unpleasant outside.
Yeah.
Going through eye drops like there's no tomorrow.
Yeah, I know people that were, asleep and they wake up with sore throats and not even sick. It's because of this. All this garbage. Alright, I'm closing in here. I know I'm close. Not as close as I thought, apparently. Okay, never mind. I can't find it.
I remember back in the late 90s, the Astronomical League, which is a large amateur astronomers organization, had their yearly convention at a ski resort up in the mountains here in Colorado at Copper Mountain, which is sort of southwest of Vail, I guess, or southeast of Vail. And there were a tremendous number of forest fires going on all over the west that summer. And the sky looked awful. They had a star party one night up on top of Shrine Pass, which is near Vail Pass. And all the out-of-towners were going on about what a wonderful sky we had. And it was a terrible sky. I guess they just didn't know any better,
That's probably true.
The sky was so bad you could hardly see anything. But they thought it was great.
Well, that's typical, Alright, I'm gonna do, let's do this. I'm getting another star for us to look at. Alright. Yeah, I think you're gonna like tomorrow's show, Daryl. I mean, it's all stuff that we have talked about before, stuff you're familiar with,
Okay.
So, and as most of you know, it's just a great show when we have folks like Daryl joining us. He has a lot of experience presenting to people. He just doesn't talk about it that much. Right, Daryl?
I don't know. You catch me in the right mood, I'll talk your ear off.
Mm-hmm. Okay, here we go. Now we're moving to another place here. Another star. We're going to be looking... Let me pull out here. Sorry, here we are. Okay. We're down by the Vail Nebula. By the way, the images came out beautiful, by the way, the other night. I'm going to actually show you those images. Okay. This is Polaris. And then once we line up on Polaris, we're going to go to the carbon star that I'm looking for in this location. This region, I should say. And there we go. Oh, look at that. You can't make this stuff up. Look at how beautiful that star is. Wow. This is the star we're at V460. Okay. And it's a C6.3 on the carbon scale, C0 to C9. It's a 6.3. Most of these stars are variables. They shrink and they bloat. They shrink and they bloat. Yeah, and its distance is just over 2,000 light years. So you can certainly see why a star of this nature would be thousands of light years away, because it's a red giant. It's a red giant. Alright, so let's bring this down here and lower it down. Okay. And we'll just do... And we're on the narrower or the wider narrowband filter, number 2. Down here you see a wheel. It says disconnect wheel. This is a filter wheel. I have 5 filter slots. The first filter slot has a narrowband filter, which takes narrow slots of the full spectrum of the red, orange, yellow, green, blue, indigo, and violet light coming from a star. Just narrow slots that correspond to locations where we know certain nebulae give off their light. Okay, and then when we use this particular filter, which is number 2, it's a same type of filter, but it's got a wider band around it, so it's a wider band of swaths that it takes through the full spectrum. All right, and 3 is just it's a spectral filter. So if we look at the spectrum here of one of these carbon stars, you'll say, wow, I'm surprised. You'll say that you're seeing green and some blue, because this is the carbon star and we're seeing some green and blue, but you're actually seeing a predominance of the red, and mathematically you could show that, but to your eye you can't see the green, okay, because that's not the predominant color that's being generated by the star, nor is the blue. You're only seeing the red because that's the main color. And if I were to just go like this and just bring up our little focus wheel here, not focus wheel, but our focus screen, okay, and bring this over, now you can actually see how this red over here is actually really bright as we're looking at the spectrum. It's actually pretty broad in the red, and the green gets weaker and weaker and weaker, and then you see the blue is almost non-existent. In a star like Vega, this blue is very pronounced, okay, and the red is weaker. This is very strong, and there's also a light out here that we don't see that's getting to us because the star is also giving off infrared as well. So it's very surprising to people that you see all the colors in the spectrum. But if you look at this, it really is slanted toward the red because the blue is almost non-existent. All right, if it was slanted more down toward this way, you'd see blue out here, and then it would go to the green and then to the red. But you're slanted toward the red with a little bit of yellow and a little bit of green. Okay, and the red is the predominant color. So that's filter wheel 3. That gives us a spectral reading. And as I mentioned before, we do have a spectrometer that's going to be going on the telescope here before long. And I went the wrong way. And that spectrometer is going to be able to tell us how the star's chemical composition is actually made, and that's going to be beautiful. Okay, so now we're going to do 30 seconds at 8,000 here, and I just got to wait until I get my fix on those stars, which I should have by now. And off we go into the wild blue yonder. Okay. This is our last pair. We looked at that beautiful pair of stars. Now the star we're going to look at is going to be a lot brighter. And you're going to notice right away that it's significantly brighter. Hey there, Papa Tom. Okay, let's see what we get. Okay, so here is the star.
It's red.
Trying to be a smart guy?
Not me.
Not you. I'll tell you one thing too, you look at stars, and I'm always drawn to the other things in the view, like these 3 little ones. Now those might just be line of sight in proximity to each other, but what if they're actually this close physically in space? It means that there's going to be, potentially, there could be some planets around these stars, possibly even some life, and maybe intelligent life. And maybe because of the proximity of these stars, they learned how to do interstellar travel quicker. Perhaps because they might have recognized the life on the other planets and around the other stars. Now these are still, some light years apart from each other, but they may have had an advantage because they're more in a cluster of 3, whereas we're not. We're actually kind of rare. We're an isolated star. But look at how beautiful that red one is. Yeah. And depending on the mass of these stars, they could either go supernova or they could just continue to collapse. But I'm really thinking that the beauty of these stars is that they go supernova. And I really want to see a supernova. Not ours, but, somebody else's supernova. Isn't that pretty?
It is.
Yeah. Okay, so let's go back to our... This is our planetarium view, and I'm going to just take down or minimize the observatory camera so we can see the planetarium view. And those of you who know how we run here, the telescope controls are over here. This is me. Hello. Daryl isn't visible because he doesn't want to be visible. He could be if he wants to. I told him he could be. And then this...
Someday.
Oh, someday could. And then this is our planetarium view, and then this over here behind it is our camera control cluster over here, and this is the live view in here. This is all the live view, and our planetarium controls the telescope, but we have it set up so in fact that the planetarium is controlling the telescope. And I would like to just back out a little bit to show you that we are near Cygnus the Swan. Okay, this is Cygnus right here. We know it because there it is. All right. Daryl talked about it the other night. Okay, we have Deneb, the tail of the swan. The midsection of the body is Solder right here. And then way at this end over here, we have Albireo. Albireo is a gorgeous double star. And we're going to go check it out right now, because I want to show you the difference between a carbon star and an F2 Roman numeral 3. K2. The K2 Roman numeral 2 star. Now, in the scheme of things, in the Hertzsprung-Russell diagram, which is our classification of stars, okay, we have the hottest and bluest to the smallest and coolest, okay, to reddest and coolest. And that goes O, B, A, F, G, K, and M. The sun's a G, number 2, okay, with a Roman numeral 5 after it. And that 5 says that we're a normal star that's fusing hydrogen into helium. So that's the way that works. Now, this is Albireo, and many people, look at Albireo and they say, wow, that's a gorgeous star. Now, one of the things is it's actually 2 stars, and they are actually orbiting each other. This is a bound pair in the sky, a bound pair. They're gravitationally bound. This blue star is this one, and it's a B8 star. If I can actually just show you real quick. Come over here for a second. Okay, and pull this up. Okay, here's the magnified view. Okay, this right here is the K2 star. It's orange, and this is the B8. All right, so this is an evolved star. They were probably both blue stars to begin with, but then as this one's lost hydrogen fuel, ran out of hydrogen fuel, it began its journey toward red giant land, and it's on its way, and now it's an F2. All right, and it's a giant. Okay, so I'm sorry, K2, my apologies, and it's a giant. So these 2 stars form that pair. The other thing is They are separated by over 5,000 astronomical units, and they're orbiting each other. I think that is really impressive because if you think about it, our entire solar system isn't 5,000 5,000 astronomical units in size. It's much less, you know. So we actually have a situation here where just these two stars alone orbiting each other dwarf the solar system. I think that's cool. So let's do 30 seconds at 8,000. Now we'll go down to 6,400 with this guy. Just a quick 30-second shot of Albireo with silly music. That's kind of funny, huh? Hey, we're gonna look at Albireo. Hey, that's right. Hey kids, we're in the constellation of Cygnus. Yeah, astronomy for kids. What's funny is I have taught all ages, and among them, I actually taught successfully. I successfully taught kindergartners the concept of light and how the spectrum works. And the teacher didn't get it, but the kids sure did. They were able to use a diffraction grating and break the light up into the colors. They knew the red from the green from the blue. And they knew that the red was longer light than the blue, being shorter wavelength. They didn't know the word wavelength, but they knew this. You could make a sign like this is blue light and this is red light. And they figured that out, you know. And I thought that was pretty impressive when you have a little kid saying to you, can I use this grating on other things to see how its light works? And the answer is yes, you can. That's a kindergartner. So, who knows? They may have embarked on a science career because of that silliness. Look at this. This is Albireo. That is just so beautiful. Now you actually see the orange light and the blue light of the star. These are just gorgeous. But there's probably no planets around either of these, as far as I know. If they were, they're probably lifeless because at some point, those planets are going to have to get close to one of the two or both stars. And the B8 star is really, really hot, has a lot of ultraviolet radiation. This one was probably a B-type star at one point, and it's evolved away. So I think that it's possible that this was a pair of hot young stars at one point. And that maybe the other component of Albireo is going to eventually evolve to a state like this as well. But, you know, it's all very interesting. Interesting fact, too, we talked about Betelgeuse dimming on SkyTour Radio some weeks ago. And we know it's dimming again. But here's the thing. Betelgeuse right now looks like an orange star, kind of like Antares, all right, kind of like Aldebaran. But the fact is, Betelgeuse used to be an O-type star. It used to be a hot blue star. And as it used up its hydrogen, it migrated off that line of normalcy that we call the main sequence, where stars are just making helium from hydrogen. And as it moved off that line of normalcy, it got bigger and bloated, bigger and bigger as it started to fuse other products, like helium started fusing into carbon, for instance. Right now, we think that Betelgeuse is in that phase where it's doing this fusion of helium into carbon. And it's going to be there. It can be there for quite a long time, a few 100,000 years. And then right now it's about 10,000 years, we think, from the point where it's going to stop being able to fuse helium into carbon. And then it's going to be making oxygen Then it's going to be making neon and then silicon. And the silicon and all these products are going to go toward iron, at least one particular isotope of iron called iron 56. That's an iron atom with all these additional neutrons to make it have, to be iron 56. And when it gets to that point, when it starts fusing silicon, it fuses silicon for only 1 day out of its millions of year life. Only 1 day. And after 1 day, the supernova happens. So if we wouldn't be able to see this because the silicon's being fused in the interior of the star. And by the time we got any clue about it, the star will have long since obliterated itself. You know? Hey there, Cheryl. How are you? Hey, my daily side. What's going on? Dave Schmidt, welcome. Bobby Burgess, hello. Lots of homework, my daily. I get you. Yeah, we actually have to do a shoot here early next week because we're doing I'm doing a show for A&E to be broadcast on History Channel, and they've got me doing all kinds of stuff. Thing is, they don't have a ready crew available to come up here because of COVID. But I have a ready crew that I can use and have used. It happens to be one of my sons who graduated film and journalism school. So hopefully they're going to accept his abilities and do that. And we have Doug Trumbull on our side too. You know, Doug today gave us all kinds of equipment from the studio to shoot with, these LED panels, lighting, and all this stuff. Because that's the kind of person he is. The man's an absolute saint. So hopefully that'll convince them that at A&E Networks in New York that they don't have to send anybody out, because I am literally going to save them many thousands of dollars on the shoot.
Hopefully they'll pay you union rates too.
Yeah, well, I don't do it for nothing because I can't, because it's time away from my shop, you know. And they're gonna shoot as long as they want to get it right, you know. And the director will be here from New York City. He'll be coming up, but it'll be interesting to see how it goes, you know. But they'll be happy. I mean, I don't think they'll be unhappy with what they get. I always give them more than they expect, so, you know, we'll see what happens, you know. And Tara, you have to get out here because I'm going to put you on the screen here too. You got to be on the show. And she can get on the show and just go, what happened? And that'll be it. That's all. She'll be there just like, what happened? And then she's gone. The camera cuts away. I've met Tara before. I know her and Marianne, of course. They're both in Arizona. They're both helping me. And that's how I know them, so I can say that. So this is beautiful. Alberio is gorgeous. Look at all the stars around here. I mean, if you had that on your wall, wouldn't that just be a beautiful image to have on your wall? Just a beautiful shot of Alberio. What a, you know. Really, really nice. Okay, let's go and look while we have this up. We can leave this up. Let's go see what else we're going to look at here. I'll have to show you guys, too, how this all came out. The photos that I took earlier, the other night. I didn't show you that, did I, Daryl?
No, you didn't.
Ah. Yeah, that's my mistake, huh? Okay, 1 second. I think I'm going to do that. I said it. I'm going to do it for you. Right now.
This is your processed images of the veil?
Yeah. From the other night. We did this the other night.
Yeah.
Okay, and everyone was here to see how the photos come in, and what I'm going to show you is how they come out once you actually do this, once you do the processing on it. Okay, here we go. First of all, let's start with Measure 27, Here is the dumbbell. All right, and let's see if this one will bring it up. Look at that. This is the dumbbell from the other night. Let me get rid of the welcome, because you already know you're welcome. Wow. Here we go.
Very nice.
This is beautiful.
The red, I think, adds to the apple core imagery.
Yeah. So this is the red border. This, if you remember from the other night, we talked about this being a bipolar nebula. And you can see this bipolarity where it's like got a mass of stuff here, okay, and a mass of stuff here with less here. Most likely this was spinning in this direction, you know, and this is the equator of the star, the original star, and this are the poles through here. So just amazing, you know, really, really beautiful.
That's very nice.
Yeah, and so this is a combination of the wider narrow band plus the very narrow band filters that I took the pictures with. Remember the other night we actually ended up losing out due to clouds, which is too bad, but it's okay. All right, now remember we did also pictures of the Crescent Nebula, if you remember. Okay, here is the crescent from that night.
Again, very nice.
Isn't it pretty though? Yeah.
Oh, it is.
Yeah.
And that little white galaxy thing down there, it starting to get that kind of comet look we saw in pictures the other night.
Right, but actually what we're looking at is that's actually just this little filamentary wisp built into this nebula.
Uh-huh.
Yeah. And then we
I
have...
didn't say it was a comet, it just looks like one.
No, I know that. I know you weren't. In fact, I know you...
Yeah.
You have to describe it somehow, and that's what it looks like, yeah. Yeah, these... I haven't put these up on the Facebook SkyTour LiveStream site yet, but when I do, they're yours free for the taking. And I'll put them up there. So that was the Crescent Nebula with the Messier 27. Then we had the Cocoon Nebula, which I took a few quick shots of. I didn't actually even get to do everything I wanted to, but this is the Cocoon, and you'll notice it has some vertical striations in it. That is a function of my photo technique, and I have to retake this set of pictures. Maybe I'll even do it tonight. And to get rid of this, I have to just keep moving the image around in between exposures, and then this will not be there. It has to do with the way the noise on the digital noise gets generated. All right, but you can actually see some beauty in the Cocoon there, Daryl.
Sure.
It's really pretty.
Got a lot of red stars in it, too.
Yes, that's right. Right, and now if we come back, then of course the piece de resistance is this one. This is the filamentary nebula of the Eastern Veil.
Uh-huh.
So that's
great.
That's just beautiful. And there's still more that can happen. And we can actually do image processing on this. You know, for instance, I could actually do a little more processing. You know, do some changes, make some changes to it along the way here. See what I mean? Kind of make it look a little better. I can show it to you like in a black and white image, right? Or I can show it to you like it's got color in it, and it's just stunning. You know? So yes, so there's a lot we can do here. We can reduce the red a little bit. Actually, that actually looks more realistic to me, actually. But this is amazing in how this occurs, why this occurs. This stuff is moving away, literally at high speed, from the source of the explosion, several kilometers per second. And as it's moving away, it's hitting other things in the interstellar medium. And these other things are places like gas that has certain densities. And when another gas comes and hits it, it compresses that gas that it's striking. It compresses it a little bit. And that compression will cause the gas to glow. And like it's doing right here along the shock front here. All right. Then other stars will get in there, and you'll see things like a star like this right here causing this area here to glow because there happens to be a localized filament that's going by this star. Okay. So really interesting mechanics going on in here. Just beautiful.
Would it be fair to say some of those stars, I think we've talked about this before, along the lines of compression in the shock front there, could that be creating new stars in it?
As a matter of fact, that is a strong possibility. We know that can happen, and it'll leave a trail of stars behind it. You know, I don't know for sure, and these might just be field stars, but here we have 1, 2, 3, 4, 5 stars in a row. Is it possible that this material is where those stars are, and as this material came through, we had 1, 2, 3, 4, 5 stars form? It's probably mathematically you have to figure out the speed at which it's moving and figure out if it's possible that maybe that could have happened there. But maybe it's possible. I don't know. I do know that compression fronts and shock fronts like that will cause star formation to occur. It's absolutely true that it will. So that's something that's really pretty. So those are from the other night, and we will come back to those at some point as well. Now, heading back to our regular view. We're back to Alberio. Hello. And let's now go back to our main view here. And that's what Alberio looks like kind of to your eye. Now, where do we want to go from here, Daryl? I know where. We're going to go right here, and I'll tell you why. This is another area in the in this nebula. It's the central part of the veil, which often gets short shrift, meaning it doesn't get enough attention. But I would like to give it some attention tonight. The last time I tried to take pictures here, I didn't have the filters I have now. So I'm wondering how that's going to come out. What do you think of that? So here we go. Away goes Alberio. Be gone with you. Whew. Look, a magic trick. And whew, it's gone.
David, we were talking earlier about YouTube ending email notifications. Actually, I just received one about 2 minutes ago. It's like an hour and a quarter old now, but I just got a notification for Mark's live stream.
Was it an email or was it a push notification?
Email. It was an email.
What the heck are they doing?
Sometimes I think they don't know what they're doing.
You think?
Yep.
Well, you're not wrong. Okay, we're on the Star Al-Jannah. Now we're going to go down to the central veil. And you'll notice that we are going to be kind of in this region. And if we look in our view, this square box is slightly larger than our actual view. If you just think of it going in a little bit all the way around, that is more about what our view is like. So here we are, a rather nondescript location. So that said, I think that we want to let me make sure these stars belong. Oh yes, they're there. Yeah, I see that. Okay, so now we are going to jump right up. We're going to go to 25,600. And we're going to go for a minute. No, let's just do 30 seconds. Just as a test to catch us. I just went 32,000. 25,600 for 30 seconds. Here we go. And we're going to try and capture some elements of the central veil. In this view, I allow you to see the pictures captured thus far tonight. And early on, when I was just starting, the sky was a little bright. That's Deneb, the brightest star in Cygnus. That's one of the carbon stars I was looking at earlier. And another one. I love carbon stars. Man, they're just so pretty. And of course... Oh, wow. Well, this I cannot say this was a failure because I can see it. So really what we're looking at is, you can see a wispy nebula right here. Really pretty.
Might your number 1 filter and or a longer exposure bring it up better?
Yes. And that's exactly what I want to do. I just did 30 seconds, see, at 25,600. So I want to do a minute shot. And let's do it at 32,000. That's approaching the maximal limit, practical maximal limit for this particular camera under Connecticut skies. Waltz of the Flowers. That's what this is. Tchaikovsky. Waltz of the Flowers. And eBay. And YouTube doesn't care whether you use these. These particular cuts are free. So, Marianne, do you have us up on the big screen in where you're sitting right now in the house? You have Randy and Diane with you up in Pine Top, Arizona right now? Is that where you are? Or you come home? I think you're in Pine Top. We're taking this 1 minute shot. It's still happening. Let me go here. So that's what it looks like at 30 seconds. Let's see the 1 minute shot at higher ISO. Oh yeah. Look at that. There's a lot going on right there. So we're going to go down a little. Okay, let's try that. Very nice, Mr. Tchaikovsky. Okay, we'll do this again. Okay, well, since you're watching it and you're on the big screen, well, if you're on the big screen, this is for you. I know, I just scared half the people out there. There, I've returned to normal. Let's see if I talk about bloating stars, red giants. I mean, this kind of gets that across, right? Stars get... right? This is
sure does.
Bloating red giant. Okay, this is how red giants will do it. You know, they'll bloat and they'll contract. And then they'll bloat again when another fusion fuel is available. Then they'll contract when it goes away. And as they contract, the core gets hotter. And then another fusion product can go and now makes the star go up again. So they'll pulsate like this. And that pulsation is something that's really, you know, kind of endemic to these things. So I think that's pretty cool. So it's a 50-inch, huh? 50-inch TV, huh? Ready to do it again. Okay, here you go. Okay, here you go. This is for Randy, Diane, and Marianne up in Pine Top, Arizona. Hello. Oh, look what we got. Look at that. Nice. See, that's the bottom of the Veil Nebula right there. That's beautiful. Looks like smoke coming off my hand. Like a magician. So there you go. I was just indulging them, sorry.
Just don't go supernova, okay?
Oh gosh, that'd be really bad. Yeah, see, this is the central veil. You can see this wispy structure right coming up here. And then there's more out here. But you know what? If you have to go that much, it's not that valuable. It doesn't give you too much. I tell you this though, there is another area within here that's better. And we're gonna go there now. It's gonna drop down. We're dropping down. And then we're gonna head west. And you'll see the star 52 Cygni come into the view. There it is. Alright. And that's the star that's right at this wisp here that we know so well. And we're going to actually go south of that. So we're going to go way down here. Okay. Now, we're going to put this right about here. So we're going to be able to see this whole bottom area. And I think that that's going to be something that you'll be really interested in, because it has a much nicer view. So we're going to drop this down to 25,600. We'll go a minute on that.
This is the part known as the witch's broom, is it not?
It is indeed. Daryl speaks wisely as usual. And we call it the witch's broom because if you look at the image here of this low-res image, you can actually see that it kind of looks like a witch's broom. So when this comes up, let's see if you can see the witch's broom. Remember, this star here is that star there. So we should see the witch's broom right around here. Remember, this is about just a little bit bigger than our field of view. So the witch's broom should touch the bottom of the field about. Very nice stuff to do. I like this stuff. Hello, Donald Kunzer. Nice to see you. I am Locutus of Borg. That's for Donald because he says, I see the outline of the Borg cube. You shall be assimilated. Dave Schmidt. Dave Schmidt says, I like the old sci-fi movie Attack of the 50-Foot Woman, but here in this case it's Attack of the Big Red Astronomer. Oh, yeah, okay. That's funny. Yeah, Marianne liked your joke, David. Look, I give you guys credit. You say something cool. Oh, look at this. Wow. Let's look at this. Wow, look at that. This wispy structure is just beautiful. Oh, see, I told you I was going to touch the bottom of the screen. I'm almost in the way. I need to move out of the way here. You know, it's like get out of the way so people can see that. Wow. I don't know.
See that fine line running along the right-hand edge too, like we saw the other night up closer to and above 52 Cygni.
Right there.
Yep, yeah. And there's some going farther down, all the way almost to the bottom.
Yeah. I think we need to take some shots.
Shock front, I guess.
Yeah, I think we need to take a few shots of this. And we'll do that with the wider narrow band, then that's filter number 2, and then we'll go back and do some with filter number 1. And maybe dare to go up to a longer exposure. Yeah. What Daryl was talking about was this right here. This is shock front right here. In fact, that little line right there that you see, that right there is the expanding cloud. Okay, the expanding supernova shock front's going that way, right? And as it heads that way, we see that the gas has been compressed along this line and caused to glow by that, right? Now, if we go down from that, okay, we see that there's more. That line continues down. Okay, it continues down here. We can see it just going right here, all the way down, and it continues actually even down into this region here, right there. So, and then it's even down more here. Look at this subtle wisp right here going off to the side there. Check that out. Isn't that pretty? Wow. Yeah, really, really cool stuff. Okay, here's the next one. And a little instant processing to kind of show you a little bit better what it's going to look like. You can see there's a lot of blue in this. Okay, so there's a lot of doubly ionized oxygen in here. Okay. Alright. And what I'll do now to prevent issues, I'm going to just move us over a little bit. Okay, and do it again. Oh yeah, man, that's pretty. That's really pretty up there. I just, I could sit here and look at this all day, Daryl.
Uh-huh.
There's so much to it. Down there, wow. Really, really something.
It would be interesting if sometime you could mosaic the whole veil.
Yeah, I actually took a photo of the whole veil with the 5-inch refractor on the piggyback mount. And it looked great, but you know what? It's also, it's not high res compared to what this would be. Once I had Bonnie on a Hada 77 is here. Hey there, Bonnie. Yeah, I mean, you're right, And it wouldn't be hard to mosaic it as long as you process all the photos the same way, take the photos for the same exposure. Mostly it would come out okay as long as the night was good.
Uh-huh.
Yep. So we are in the Western Veil Nebula, folks, and we are just below the star 52 Cygni, which is right here in the view, up there. And 52 Cygni, where it actually lives in the nebula, here is the entire veil right here. That's the whole thing. The images I showed you earlier tonight was this side. We took a couple of the center of the veil here, which weren't so bright yet. And then now we're taking a picture not of this spindly part up here, but from here down. You see this really interesting set of filaments down here. So that's what we're doing. And why not? It's beautiful. Okay. So how are we doing here? Let's move this and take another one.
Why are you moving it slightly? You said a minute ago, there's something about you were getting some red bars in the image earlier.
Yeah, the movement actually, it allows you to get rid of the noise that ends up being systematically visually apparent in the image. So you only have to move about 6 pixels. So I'm moving way more than I really need to, but it's okay. I'm moving just enough, and it really is a nice way to get rid of that noise, so that this resulting picture is going to be much more workable. Remember when I showed you the other images? Okay, we actually had in that one, we actually had a very, very clear look. It looked like you were looking at it through a screen door. And that's this problem, So we have to get rid of it. So we have to move it. Okay. Hope you guys like the carbon stars we looked at earlier. I thought that was pretty cool. Keep in mind that when we look at every photo we take, there is a possibility that there are carbon stars here lurking, or small M stars. That's going to be a beautiful stacked set of images, man.
I bet.
Look at that. Telescope's performing flawlessly. I'm enjoying the fact that the telescope is flawlessly working tonight. Alright, and we'll take another couple of these, and then we're going to go into the narrowband realm. If anybody has any questions out there, let me know. I will be happy to tell you I have no clue, because I don't know anything about astronomy, and then I'll just tell Daryl to answer it, and he'll say what? And that'll be the end of that. He'll probably do fine. Seriously, if you have questions, I'd be happy to answer. We are settling in for a series of photos of this area of the Veil Nebula. I really think this is going to end up, this part really is going to end up looking really spectacular. I'm going to make it look spectacular. Yeah, these wisps are really something, David. And here's a little processing, and you can see it a little better. And if we do another, yeah, that's a sharpened view. I don't want that. That doesn't work well. Can you believe that there's this type of gas through? I mean, this is several light years. Can you believe that this type of gas is actually out there in the universe, just like spread throughout the universe?
Sure. That's what we're made from.
Yeah. As Carl Sagan said, you know, we are star stuff.
I knew you were going to say that.
I know you knew I was going to say that, because I always do. I don't seem to get away from it. But he was my favorite astronomer, of course.
Oh, me too.
I'm going to run back.
I remember seeing him when I was a youngin' on the Johnny Carson show.
Oh, yeah, he was actually a frequent guest on Carson, wasn't he?
Yep, that was a long time before he did Cosmos.
That's right. It's like, hello, Johnny. Hey, Carl. Ha, ha. And Carl Sagan. Yeah, it was a great show. And Carl Sagan was, you know, a consummate entertainer and astronomer. And I think I like that most, because he could pull in a child who loved astronomy but didn't really know a lot about it. But he could pull in a child and have that child sit there mesmerized like this, you know, for an hour, you know. And that's a long attention span for someone like me. Dave Schmidt, question?
Read a lot of his books, too.
Yeah. Hey, Gina. Gina Leone is in the house. So good to see you guys. All right, here's the question, David. Oh yeah, very good question, David. You know, and that requires going and take a visit. Okay, so you look at this curve right here. All right, this stuff is curved right here, and the reason that's curved is because when it blew away from the star, it blew away in a roughly spherical direction. So there's some stuff coming at you as well, like this, and stuff going behind as well, and stuff going to the side and all around. So it was a spherical detonation. The stuff coming toward us and away from us is mixed in into this view, of course. Now we're seeing this on the edge, okay? That's the edge of the expanding edge there. But one of the things we want to look at, and that we actually care about, this is beautiful, is that this curve is due mostly to the fact that as it expanded out into the interstellar medium, okay, it hit areas of density out here, some other dense stuff. And so what it did was it held back certain edges of this wisp and certain edges, and some would get through, and it ended up curving it in certain areas. It didn't do that everywhere. There's some areas that are almost flat, some areas that are actually protruding because they're actually less resistance there, more resistance back here. So what you do is you think of it as like pressing clay up against the grating. You know, the metal of the grating is going to hold back the clay, but where it isn't held back, it squishes through and makes little blobs sticking through. That's kind of what's going on in the interstellar medium, but it's a much less dense medium. So I think that was the flavor of your question, but let me know for sure, and I'll be happy to rephrase and help you with that. Daryl, of course, you can add to it as well, naturally.
Thank you.
Hey there, Cheryl, Texas. Pale blue dot, yes. Excellent.
Among Carl Sagan's books, the one I didn't care for so much was Contact, the one with Jodie Foster they made the movie of.
Yes.
I thought he kind of waffled about aliens. He never really committed to it.
No, but that's a political reasoning there. There's tenure involved, and there's university politics that had to be played there.
Sure.
Unfortunately. Okay, good, David. Yeah, you're seeing different densities of the interstellar medium that cause this thing to be shaped differently as it expands outward. That's kind of how it works. Okay, we're still in the middle of our 1 minute shot here. Now we're done. There's the next one. Look at that. Oh, wow. Let's do process. Look at that. Yeah, we're going to end up getting an awful lot of data out of this. This is going to be really good.
Cool.
Yeah.
They're laughing at you, Mark.
Oh, really? Oh.
They captured that big picture of you and are sharing it now, I guess.
Oh, I could actually really do the worst. I could do it worse by making the big picture and making a funny face, and then that would actually be the one that gets all over the web. My luck, the A&E guys will see it when they come up here to film, and they'll be like, oh, we don't want to do this anymore with you because you're too silly. So,
Mark,
yes, sir?
While we're waiting on the image, could you put up the stellarium view of the area?
Of course.
And if you could overlay the grid on it, could we get an idea of how big the entire veil is? Like degrees across or whatever.
Okay.
There you go.
So let's bring us up to here.
Yeah, what are the grid sizes?
Okay. This is 1 degree. I mean, we're talking about it's
almost 3 degrees across.
Yeah, it's bigger than it's 3 times the size of the moon at least. Yeah. 4 times the size of the moon. And now the picture's ready. Let's see what it looks like. Yeah, look at that. Yeah. Now I'll just go start another one after jogging it back a little bit. Yeah, that's good. Go up a little bit. Now I want 52 Cygni just barely in the view. So
Tara asks, do we know if there are any remaining nebula remnants from our solar system formation, or can we not tell from our perspective?
Tara, that is remarkably prescient of you to ask, and I'll tell you why. That's one of the perplexing puzzles that astronomers have is, where's the remnant of our formation? And on Sunday night's show, actually, we're going to talk about that, Daryl. We're going to actually we're going to go right down that very path. And among the things that will come up is, there are some nearby star clusters that, and groupings of stars that we were once thought that we were part of originally, but
Ursa Major moving group.
the moving group, yes, as well as Measure 67.
Are you saying that's no longer thought to be the case?
That is true. It's no longer thought to be the case. So it's a toss-up now, as far as where we come from. Because the question is, one of the things we're going to talk about tomorrow night on SkyTour Radio, it'll be 8 to 10 Eastern Time, is where was the sun formed? Or as Kirk would say, where was the sun formed? I mean, if it was formed far away, then we shouldn't be here. I mean, that's just his inflections, not really his voice. But the fact that we were formed at some distance from where we are means that the universe has had time to dilute the presence of any gas and dust that might signify a starting location for where we came from. So we don't really have a clear idea as to where we came from in the universe. We don't have a starting point. And you got to remember that since we started, we've gone 19.5 times around the galaxy. A lot of mixing, a lot of star movement, a lot of gas clouds passing through and by over 4.6 billion years. So our origin location has been pretty well diluted and hidden. But we're still trying to figure it out, because guess what? We're also going to talk about one other thing. We found the sun's exact twin. That's right. I mean, I'm not talking about a G25 star, G spectral type, or class rather, and the G2 number 2. I'm not talking about that. I'm talking about right down to the chemical composition. Every star had like fingerprints. They're like fingerprints, okay? The fingerprints are all unique on every single person. That said, the star's chemical compositions are also unique, and stars that are born together in the same cluster will have the same fingerprints. Well, guess what? We found our left hand if we have the right hand. If the sun's the right hand, we found the left hand. And that star is moving in a particular direction, and now we have to try and reverse engineer where it's been, where it came from, and see if we can mathematically, through computer models, find a common point of origin for both us and that other star. This is critical. Now that we've found our twin, our literal twin, we can find our origin, our birthplace, our place in the universe. And I think that's really amazing. I can't wait. I want to be part of that somehow. I'd love to do that. Don't know how, though. But you think about that, that's really just a perplexing question that should be kind of like the question of the century. Is like, where was the sun made? Were we born in a cluster? Were we born in a nebula, as Tara asks? I mean, and the answer is we're probably born in a nebula, and that nebula made a young cluster of stars, of which our sun's twin that I just mentioned was part of. And then over time, the stellar winds from those stars and our solar wind dispersed that hydrogen gas within which we were made. And now that's just neutral hydrogen out there running around, in between the stars. And so that's possibly why we don't have a direct view into a remnant. But I'll tell you, it's a really good question, isn't it? And it's really one of those wonderful ponderables, as I say. Yeah. Yeah, gas mask. It's amazing. You were going to say something about that, Daryl?
No.
Oh, okay. I heard you. I thought you were going to start to say something. Yeah, it's really quite a... Okay, we're still just finishing up this one. There we go.
Actually, I was going to say, would you excuse me for a moment, please?
Okay, but what if I want to go somewhere?
Well,
Let's
I
go.
claim first,
You
so
go
you get
for it.
second.
You go right
Be
ahead.
right back.
I'll be right here. Guess, Mass, that velocity, you're saying how fast is the Milky Way galaxy moving around the galaxy? Do you mean how fast is the galaxy rotating? How fast is the sun moving around the galaxy? Tell me what you mean by that. Also, interesting note, guys. When we look at a galaxy, if this is a galaxy, all right, we know that just like with a solar system, you would expect the stars to move faster around the center and slower around the outside, just like Mercury speeds around the sun in 88 days, and Pluto takes over 250 lazy years to go around the sun once. So we figured that stars in the center of a galaxy are going to speed around pretty quickly, and stars outside take a little leisurely time to get around. And we're about halfway out, maybe a little more, a little less, and we'll have a certain rate too. Well, it turns out that the rotation rate of galaxies, of our galaxy and others, it acts more like a solid disk. So the stars in the center are not moving very fast at all, and the stars on the outside are whipping along at unbelievable speeds. Now, that is a very strange finding, because it seems to violate Newtonian kinematics, that is, the laws of physics that dictate how things that rotate like that should rotate like that. So one of the things that's interesting is that when you work this out, you find that there has to be another type of matter that we can't see that's affecting and causing the galaxy to rotate as almost like a rigid disk. It's not quite like a rigid disk, but almost a rigid disk. That means that this other type of matter is something we have to find. We only see it indirectly by the rotation rate of the stars within the galaxies. But how do we actually find it? The way we actually find it is, well, it's actually something that we don't have a way to do yet, because it's dark to us. It's just sort of a dark matter that we can't reach into this black box and figure out what it's made of. And that, of course, is what we decided to call it, dark matter. We see it only because we infer its presence, and thus the concept of dark matter was born. All right. And in terms of the reason why you've heard the term dark energy is not dark matter. Dark energy is an energy that seems to be pushing space itself away from itself in every direction, every location, all throughout the universe. Now, it's a repulsive force. And by that, I don't mean it's repulsive to look at. I mean, it's pushing away in all directions. A way to visualize it is if you have a balloon and it's deflated and you put dots on the balloon, and then you blow up the balloon, all those dots that you put on the balloon are all going to be moving away from each other. Every time as the balloon blows up, they'll all be moving away from each other. That is a good way to visualize the expansion of the universe, but it's also a good way to visualize how dark energy interacts with the interstellar medium. It's a repulsive force that moves space away from itself in every direction. Same way. And the reason that dark energy came to be was because when we looked at the galaxy, all right, and we looked at how galaxies far away are acting, and we calculated what's called the recessional velocity, that is how fast galaxies are speeding away from us because of that expansion I was telling you about. We know the universe is expanding. Calculating the expansion rate in 1929, Edwin P. Hubble came up with a constant value that he said is the expansion rate of the universe. And we've been using that in all of our physics, all of our calculations, all of our science. Okay? And then along comes a spider in the form of the Planck telescope and others that were working primarily on looking at the 3-degree background radiation, the CMB, cosmic microwave background. And these telescopes turned up a very interesting set of numbers that seemed to indicate that the expansion rate of the universe, as agreed upon for the better part of almost a century, turns out to not actually be a constant after all. In fact, it seems like it's getting bigger. And that is to say that the expansion rate is increasing. Now, that means that the expansion rate from 1929 to the expansion rate in 1960 to the expansion rate in 2020 are all different. That means that the universe is expanding, but it's accelerating as it expands. It's accelerating outward faster and faster and faster. Now, what does that mean? What does that mean? Well, it means that there's another force out there that is causing the universe to expand away from itself in all directions. And that will accelerate the universe outward. And that is where dark energy came from. So I find that to be fairly interesting. Hey there, Jeremy Blaine. How you doing? I see you type nope. I don't know what that means. Let me know. If nope is something you want to talk about, let's do it. Okay, one more.
Back.
Yeah, I heard you.
Yeah.
Okay, let me just go back this way a little bit. Okay. All right, and we're gonna get that to hang solid. There we are. We'll take another shot here. Now we're gonna go to our other filter. Hi there, Fantasy. How you doing? Jeremy Blaine says astronomy is totally wrong right now. They have no idea what's going on right now. Well, I'm an astronomer, Jeremy, so I won't argue with you and say that we know everything, because we certainly don't. So you're right about that for sure. But there are some things we can know. When you say they have no idea what's going on right now, well, that's sort of a blanket statement that doesn't really help. I mean, if you have a specific thing that you'd like to talk about, we can probably maybe agree on it or not, but I'm happy to talk to you about it, because I don't think astronomy has all the answers, nor do astronomers. They, you know, if there's any science where we're always learning more about the science, the objects we're studying, it's astronomy. And don't forget, the only way we know astronomy is by looking at the light we see coming from all these objects. We can't touch them. We can't touch the objects we study. You know, so you might not be wrong about this. You know, there's certainly places where it's true, and there's people out in the astronomy world that, you know, the very few that are actually arrogant about it and don't want to hear it. Okay, but the fact is, you know, if we don't know what we're talking about, we don't. You know, if we don't have a clue, then, you know, that's one thing. That's right. The age of the universe is off. You know why? I just explained it. Jeremy Blaine says, you know, start with the age of the universe is off. That's correct. That's because of the Hubble constant, which I just explained. You know, that expansion rate implies, if we had a solid expansion rate, oh, Donald, it's okay. He's just asking questions, and that's fine. The expansion rate of the universe we thought was a certain thing, a certain rate, and so we reverse engineered that, see, and we came up with a age of the universe based on our reverse engineering. And you're absolutely right, Jeremy. The age of the universe is off, and it might be off by almost 1 billion years. And the reason is because, as we found that the Hubble constant wasn't, it turns out that the universe is younger than we thought. Because if we're accelerating outward, that means that the Hubble constant has been changing all along. And if you have to account for that, the universe might be 12.6 billion years old, not 13.8. You know, or, you know, less than that. you know, okay, good. I'm glad you're listening, Jeremy. That's good. But yeah, but see, the thing is, that's the thing. You know, there's no ego here. You know, there's no arrogance here for me. So, you know, I know that science, astronomy, as much as we know, there's a lot we don't. And you know, we're in our infancy when it comes to the science of astronomy. We only know what we know to this point with the science we have. I think that it's important to understand, though, as you point out, that the expansion of the universe is a very, very important characteristic that we need to understand better. Because is our universe 13.8 billion years old? Or is it 12.6, 12.4? I've heard numbers all over the place. The acceleration of the expansion is the reason why this all came to be. And I am pretty sure that these numbers will show that this expansion rate of the universe is actually accelerating and isn't a constant after all. Edwin Hubble came up with a value in 1929 with technology at the time. That technology at the time probably wasn't the best technology, you know. So you can still take photos, you can still take measurements, you can still get radial velocities, you can still get recessional velocities of galaxies, because that's all based on spectral analysis. All right. But I will say that when we talk about things in astronomy, well, and before, earlier, Jeremy, I said something else that goes to your point, and that is, you know, we thought that galactic rotation worked a certain way, and then we found that it didn't work. When we actually studied the motions of the stars in the galaxies, it turned out that these stars were all moving at roughly the same rate, you know, as like a rigid disk. That totally violated our science. It felt like we blew Newtonian kinematics in physics, but it's not true, you know. So I think that it's important to keep that in mind, that, you know, we don't know everything, and to think we do is just, that's the silly, embarrassing arrogance of the 1800s. The 1800s astronomers, their arrogance is legend. You know, luckily I was not born then. Yeah, you're right, Jeremy. Jeremy says there's a lot of arrogance with some of the researchers, the mainstream. And some of that is not necessarily arrogance, but commitment to their beliefs in their data. And some of them are right, some of them are wrong. No doubt about it. And it's the mark of a good scientist to be able to say, I know some of it's right and I know some of it's wrong, and so I need to have an open mind, kind of a thing. And that's a very important aspect of it. And one of the things that you find a lot of scientists and astronomers, in fact, will have open minds. It's kind of weird. I mean, when it comes to, say, extraterrestrial life, okay, I'm an extraterrestrial life guy. I think that there's extraterrestrial life all throughout the universe. I wrote a book on that. In fact, all over Amazon, you can get it. It's called The Populated Universe. And I discuss the prospects of extraterrestrial life based on how we formed and how we operate, how we're built. We're carbon-based, bilaterally symmetric creatures. And our chemical composition is a common one in the universe, apparently. So that means that we're not the only ones, at least based on carbon. And it means we're not the only ones based on DNA. Look at all the many millions to billions of life forms, past and extinct, that all had DNA. DNA is a template from the universe. It's a template, you know, clearly. So is carbon-based life. It's a template. The universe provides this material by itself, and the Earth makes this material. You know, so we are here because of the fact. Oh, this is beautiful. We are here because of the fact that the universe, if it had a will, I would say it wills it so. But we are here because the universe makes it possible for us to be here. And it's possible there's other universes. What's the plural for universes? Universi? Universi? That kind of thing. So it's possible then that we are actually, working our way through all this to get to a final understanding of science. And we're not there yet. We're certainly not there yet. And to say we are is ridiculous, But, and Jeremy says, and I'm really happy you joined us, our stream, by the way, Jeremy. That's really cool of you. You got some really cool insights and some observations that are nice. Your point of view is well taken too. You're kind of astonished by the fact that we're on this ball flying around at very high speeds. And to argue with people that think the Earth is flat, for instance, is the exact opposite of like talking to someone like you. You're reasonable. You have a head. You're intellectual, and it's very important to draw that line. In fact, you've joined a lot of people like you in this chat, because everyone here is like you. They have questions like you, and they have insights like yours. So you can learn a lot from these folks, and you can also learn a lot from Daryl and hopefully myself as we take you through a lot of the interesting things that we are doing here. Right now, I'm actually going to go back to filter number 1. This is the narrow band filter, so of the entire spectrum of red, orange, yellow, green, blue, indigo, and violet, we're taking a small slice at 4 different locations in the spectrum to actually get the image of this nebula a little clearer. So this is now same ISO, same time, but with the specific filter. That's right, Jeremy. I don't believe we're alone. And Katie Q, see, I told you, you got a lot of people here that think about this stuff, Jamie. Look what Katie Q said. She said panspermia. Well, guess what, Katie? You might not be far off. There's some evidence to indicate that maybe Martian meteorites came here when Mars was hit with a death blow impactor at one point, and this Martian organic material that may have been life-bearing was blown off the planet and possibly reached us. Now, the Earth made its own carbon-based compounds and amino acids. Left on its own, the Earth does that by itself. And meteorites have delivered amino acids, and comets have delivered hydrocarbons and amino acids in water, as well as asteroids, same thing. So I think that when you look at the combination of the processes that could lead to life here, we end up having a lot of help from the universe, Okay, now this, you can see, look at how the wisps show up even better. And Daryl, look at this. This is the new one here. That looks much more pronounced. So, I'm going to come back now, and I'm going to move that over, and I'm just going to do that again.
Those are the bristles in the witch's broom.
Oh, come on. Why does she have to be a witch?
Hey, it wasn't me.
I know. Yeah, gas mask. I know a bunch of the guys on the Nimitz incident. Like Day and Patrick. I have never met Fravor yet. I'm sure I will. But the other guys in that incident, they're all together on this. And you couple this with weird things that they saw, with the stuff I saw when I was on a nuclear sub, and I was just a guest for one particular cruise, and we saw a very high-speed object go through the sonar, unlike anything that any Navy at the time had. This was decades ago, by the way. And it was moving at several hundred knots, according to the sonar guy. And the executive officer basically told him to log it and then bury it. And a few years later, I had to do a job for the Joint Chiefs down in Washington. And I was actually sitting with one of the chiefs at his home. And I asked about what they called on the sub as fast movers. And he looked at me and he could have said, I have no idea what you're talking about. Or he could have said, I don't know. Instead, he looked at me and he says, oh, I'm sorry, Mark, I can't talk about that. And I was like, you see, that's someone saying, yes, it exists, don't ask me anymore. And I was like, oh. So, yes, that's very important stuff. That's very important findings. And when we talk about extraterrestrial life, you know, again, how can you actually say that you don't believe in extraterrestrial life? I mean, no one here does, okay? But how can anyone possibly doubt that there's life elsewhere in the universe? Do you know there's still people that doubt that there's life elsewhere? But how can you doubt it? All you have to do is look at us. Look at how we developed. I mean, we got nearly destroyed 5 separate times in our evolutionary history. And here we are. We're still here. I say we still evolved. Because every time we had these major extinction events, we weren't here yet in terms of evolved species. But the planet still supported the evolution of more intelligent species over time. It doesn't mean that that's a foregone conclusion, you know. Because it certainly doesn't. And I mentioned that in the book too. I talk about the surge of intelligent life on the planet. It's a potential destination, but it's not a foregone conclusion. It's not a guaranteed, outcome, guaranteed path. Okay. I mean, if we got hit by a killer asteroid tomorrow, it could technically extinguish all life on Earth. If there were people that weren't, killed outright, it would be a few weeks later when something else went wrong, like it got too cold or whatever. Oceans froze, water, no more water. I mean, a lot of possibilities. KDQ, you said you had an experience in Mountain View. I actually have good friends in Mountain View, actually Palo Alto, and I've been to Moffett Field. I wasn't there in 2016. I think I was there. When was I there? I think it's before they converted the blimp hangar. So what was your experience, KDQ? I want to hear it. $1995 in British Columbia. Understand that gas mask. It's an easy subject to be hooked into. And you know what? It's not often you're going to find, someone who does astronomy who also says that they also believe that intelligent alien life could be here. But you know something? My book details concepts about how interstellar travel is possible. And it even mentions how NASA's currently paying a lab to investigate interstellar travel possible over the next 100 years. And now, why would they do that now? Because it takes foresight to do this. If you don't start sometime, you'll never do it. So, basically, interstellar travel can happen. It doesn't violate physics if you do it using certain techniques. A warp drive, for instance, which you might think is Star Trek, but actually is not. It's Miguel Alcubierre, okay, 1994. Okay, Miguel came up with this amazing concept where he actually was able to fold space given the right amount of energy, and you just transfer across the tiny gap from like two folded corners of paper. You fold them up, cross that little gap at the top, unfold it. Now you've gone, some distance. It's huge. So you just fold space over and over, fold and unfold to make your trip. And there's no limitation on how fast you can literally pull the universe past you during that time. So there's no light speed limit anymore. And you could literally go many times the speed of light effectively. So in other words, from here to Alpha Centauri is 4.3 light years. And that means at the speed of light, which corporeal physical beings like us could never go, because that brings you up to that makes you pure energy at that point. At that speed, it would take 4.3 years to get there. Well, how come with the Alcubierre drive then, and actually specifically a variant of it called the Froning Alcubierre drive, you can actually do it in about a week? Now, if you do the math, you'll say, my gosh, you've gone hundreds of times the speed of light here, maybe more. How could you do that? Well, the answer is we didn't violate a darn thing, because we just kept folding space and jumping across a tiny gap. And that process of the warp process makes it very possible. And, so it's kind of cool. So I'm going to read this from Katie. She was talking about her experience, and I want to give her she's writing it out. I'd like to read it for her. We were driving home from work and saw a large trapezoid-shaped object from an overpass, which was just in front of the Eastern Hills. Not sure what they're called, beyond Milpitas. Okay. This was during rush hour traffic. Had to keep cycling around to get back to the overpass. He must have driven around 10 times. Okay, each subsequent time we saw 3 different tic-tac shaped objects rapidly moving laterally and also spinning in place, which actually gave the appearance of dust being kicked up on the distant mountains. One of the last times we drove around, we saw a cluster of light silver orbs moving rapidly between the tic-tacs. Okay. Very interesting. So where are the photos, Katie? That's amazing, though. Yeah. And then Gas Mask has one, too. Let me go back to see where he starts. Yeah, he's been hooked like we all were. Oh, thank you, Tara, for the comments on the book. You're just saying that because you were my editor. You did a wonderful job. Gas Mask and a friend saw a hovering giant silver pinball with black markings when we were on top of a mountain overlooking Lake Elsinore, California. Where's your photos? I've also seen a giant bar of light go overhead that turned the night into day, caused all the bugs to become silent for what seemed like 5 minutes. I've seen that too, actually. In my case, I don't know if that was the same for you. Good, Katie. I'd like to see those stills. In my case, what I saw, though, I identified as a Earth-grazing meteorite. It was so bright in the sky that you could see your shadow by it, and it was at night. And as it came through the sky, it actually broke up into 3 distinct segments. And then a few minutes later, you heard, you actually heard it explode. Really impressive. And you could see these red hot fragments. I was like, wow, I want those fragments. I want those fragments. But they probably landed out in the water somewhere. It was heading toward the ocean, toward the Atlantic. But I'd like to hear more on Gas Mask. Let's go up here, go to settings. I want to just do For the bulb shooting, we're doing a minute 30. Okay, how about that? We're doing a minute and 30 seconds the whole time. That's good. Yeah, we're getting a lot of good photos of this tonight. This is really good. So I'm gonna turn this into hopefully we'll turn this into gold. Gas mask, that's fine. I'd like to see it. And for those that may or may not know, the Mutual UFO Network is an organization that's had its ups and downs, some downs lately when our international director was, arrested by authorities. But, we move forward, every organization has its warts. But I've been in this organization since I was 11 years old, and that was 2 years after it started, actually, when I got a membership. And so in the organization, my role is I'm the chief photo and video analyst, so I see videos and photos from all over the world. I also spoil a lot of people's fun, unfortunately, because I give an opinion of something based on many years of experience. Is that okay? Gas mask, I should assume that link is to your video. Okay. Daryl, are you reading what they're saying too?
Sorry, yes, I am.
Okay. I don't want to.
Yeah, gas mask looks like a link. Katie said her BC sighting, we were tracking satellites when we saw a small red dot appear from behind the tree line, which we thought was a satellite at first. It split into 3 red dots. The 3 dots moved rapidly in tight geometric patterns for about 10 seconds before they re-emerged and then exploded in different directions very quickly. The family we were staying with worked outdoors and camped throughout an area of BC, which they said they had seen the same exact thing.
Okay. Okay, I see. Huh. Oh, Katie Q, if you have a link, let me know. You can reach me if you want to send it to my link. It's mufonanalyst@gmail.com. Kind of easy to remember. I'm just rocking out on this blues, man. This is the kind of stuff I like to play on guitar. Hear that guitar back there? I just love that. Nice. Well,
may I relate a couple of instances?
Absolutely. First, I want to say hi to Isabella, but go ahead, Daryl.
Okay. The first one, I don't think it was the first UFO I ever saw. I'm not sure I've ever mentioned this one before. I was at an outdoor party back in Missouri about 1975. Somebody else pointed it out to me. We were a bunch of people out milling around in the dark, and I was not exactly sober, which has always colored my feelings about this. Some guy shouted, "Look," and pointed straight up. And I looked up, and I saw approximately 8 little silver, what would you call them? They were bigger than stars, but they were small. If they were discs, they were very small. About 8 of them, they were moving abreast from south to north very rapidly, but at the same time, they appeared to be either crossing each other's paths or veering back and forth, where they left a sort of weave pattern behind them. And again, I was, not sober. They were moving so fast. I mean, they came and gone in a matter of just a few seconds from what I saw.
Were they leaving a trail?
Huh?
They're leaving a trail?
Maybe a short trail, or maybe that was just the alcohol, etc. Hard to say, but there were about 8 of them. It was hard to tell. They were moving so fast. And again, they were moving from south to north. They were moving abreast of each other. They were in a line going across the path they were moving.
Okay.
And they were sort of weaving back and forth. They were either crossing each other's paths or moving back and forth each one. And it would have made a basket weave sort of pattern in the sky. And they came and went in just a matter of seconds.
Wow.
I'm not sure I've ever told that one before. I've always kind of doubted myself about that because of the condition I was in at the time. Again, I was not sober, to put it mildly. The other one, I saw a bunch when I lived up in Leadville, Colorado, highest city in the United States. This one in particular, I had been at a friend's house out southwest of town, and we had just watched the original Chris Reeves Superman on HBO. And I was driving home, headed sort of east-northeast toward Leadville, and the Mosquito Mountain Range was in front of me. I was facing it as I was driving up the road. And this bright light came down from upper right toward lower left in sort of an arc motion. It was a bright green light with a white light on either side of it. And if I ever saw a UFO that looked like an object, this was it. It was all 3 lights were steady and evenly spaced, a white light to either side of a bright green light. And it moved in a sort of a curved path as it went from upper right to lower left. And it went behind a hill. And that was it. I told a friend about this later, and he said he was up around that hill. There's a place called Birdseye Gulch, sort of northeast of Leadville. And he said they saw it land. He may have been pulling my leg, but he said they saw it touch the ground. And that was the second one.
Huh.
I've seen quite a few UFOs in my life, and these were probably the 2 most striking. Again, I don't call them flying saucers. They were UFOs because, by nature they were unidentified. Mm-hmm. Those are 2 of the more interesting ones.
Well, I think that there's a lot of problems occur when people are viewing these things. Humans are not professional observers. No one is. I'm not. No one is. But we all think we have certain things we understand. But the problem you have is when someone relays a UFO report to you and they say, this thing was about 500 feet up, it looked like it was 1,000 feet across.
Right.
You can't trust any of those dimensions. It could be a big thing that's far away or a small thing up close. And 2 studies were done by Stanford University and by the Eye Institute, and they showed that when people are trying to identify stuff in the sky, that humans are not evolutionarily designed to give you proper distances for those things because there's no references. When you have a tree and you say the bear was behind the tree, therefore the bear was about 200 yards away, that you can do. But when there's no references in the sky, we're not good at that. And so when people say that this thing had to be 5,000 feet across, this was moving 4 million miles an hour, 1,000 miles an hour, none of that is valuable information. What's valuable about the information is Do you have some photos? Do you have a video? Is there another witness? Do you have someone that can tell us about it? What did you see versus what did you see? And see if the two stories actually connect. You know, I've had people, like, for instance, okay, give you an idea. A meteor that grazes the Earth's atmosphere. Earth is a ball, contrary to popular belief. And as a meteor crosses into the atmosphere, it can actually be forced to glance off the atmosphere because of the nature of its shape, its speed, and the angle at which it hits the atmosphere. It can sort of skip like a stone on water and go across the atmosphere. Well, when you see something like that, a meteor like that can be visible across multiple states of the United States, okay? You might have a sighting that is seen all through Connecticut and all over New York, right? And terminates in New York somewhere, maybe. So you can imagine my excitement when I got a call at 3 in the morning, and I was actually asleep, and it's from some police force members, and they're asking me if I could talk to them right now. And I said, yeah, what's the matter? And they go, well, we have a guy on site right now, a police officer on site that says he just saw a UFO crash into a lake. Now, he goes, we've received reports that something was crossing the whole state, and it crashed right into the Bantam Lake in Bantam, Connecticut. Wow, that's about 12 miles from me. Ooh, I'm going to go see. And so I went there and I looked at the site, and I thought, my first thing was I went right to the boat ramp. And there was actually a state trooper there, and I talked to the state trooper. And I said, this is where they're saying it crashed, in this lake, in Bantam Lake? Yes, sir. Okay. Nothing crashed here. What? How do you know? Because the boat ramp doesn't have any water run up on it at all. If something hit, it was going to hit the ground at literally in excess of probably a mile a second. And that's at the low end. That was probably could be up to 6 miles per second. All right. We're talking about something hitting at a very fast rate based on what they're saying. So I said, we don't have any water damage, any water run up whatsoever here. We would have micro tsunamis coming across this lake. If it hit in the middle of the lake, this entire boat ramp would be flooded by debris and water. It'd be all wet. And in the morning, they looked around the lake actually with a boat and then the helicopter, and they said, nah, there's nothing that indicates that this lake had anything strike it. And I said, yeah, here's what I think happened. And I explained how I thought it happened. When you have a meteor strike, okay, you will see, in fact, people will say that the meteor struck and it hit this particular location. But what's happening is you have to remember that with these earth grazers, earth grazing meteorites go horizon to horizon. And when you watch a jet go overhead, it's over your head, you watch it go, you watch it go, you watch it go. As it gets to the other horizon, it's getting lower to the horizon. And if you could accelerate that to the speed of a meteor, you could easily see how the plane would look like it's going down and heading into whatever is near the horizon from your local position. And if that local location shows a lake, then you might see this highly illuminated streaking meteor colliding with the lake. You'd see the image of it in the lake meet the image of it as it's passing the horizon. And you'd say, wow, it hit the lake. And that's exactly what happened here. And it turns out that it never even made it to the Earth. It was actually a grazing meteor. But it went across the entire state of Connecticut. And it continued across parts of New York. And so that was kind of a neat thing. But you know what? It's an interesting little... it's an interesting event because you can detect meteors easily enough. We're going to actually add a meteor detector in our observatory, by the way, Daryl. And we'll do this in Arizona. We're going to do that here. And it's a meteor radio, believe it or not.
Uh-huh.
You can convert a regular radio to listen to the sounds of meteors entering the atmosphere. If you remember AM radio, amplitude modulation, that stands for AM, instead of frequency modulation, FM radio. Yes, radio, that old thing. Amplitude modulated radios would always be able to detect thunderstorms. You could hear the sizzle of lightning from miles away. You hear, static while you're hearing in the radio. And that was actually due to the fact that we are listening to lightning, okay, that's actually interfering and causing electrical interference in the atmosphere. And the radio waves are bouncing off the atmosphere, the upper atmosphere, and they're being messed up by this lightning energy. So we hear this up in the atmosphere, and it comes down to our radio antennas. So there's ways to listen to meteors in the same way. And basically, you just have a little radio, which is silent, and all of a sudden you might hear, beep. Hey, what was that? Beep. It makes a little high-pitched whine. And that's the meteor radio. So we're going to have one. We'll have the radio on, so all during the course of the night, you'll hear beep, beep, beep. It'll be for meteors you don't even see, and you can't even see. And you'll just hear the meteors. So you'll be able to count up the meteors that you hear during the night. Be kind of cool. So that's an added thing that we're going to have in both locations. So it'll be really neat to do that. And it's because of the way they interact with the upper atmosphere and what they do, and how they're and with their speed, how they interact with the molecules up there. So neat stuff. We'll be doing that too.
You touched on something earlier. Could I expound upon a little bit? When people try to describe what they see, how they see it, they can only relate in terms they know. And so they say, well, it was 10 feet across and it was 500 feet away, stuff like that. What people should learn to do is to express, this is especially valid like for meteor sightings, you need to know azimuth and altitude, what direction it came from, what direction it was moving, how high it was, and you're measuring things in angles, in degrees. If you stick your hand out at arm's length, your hand is about 10 degrees across, okay? And 9 hands will go from the horizon to overhead, 90 degrees. And the horizon is 360 degrees around. From north to east is 90 degrees, et cetera, on to south. West is 270 degrees, and back to 0 or 360, which is north. Try to express things in angular terms, and don't say, well, golly, it was moving 1,000 miles an hour. Say it was moving 10 degrees per second, And if you base everything on the width of your hand at arm's length, you can give much more valid information than trying to equate things you see in the sky to inches, feet, miles, etc., etc.
You have spoken wisely. That's a very intelligent way to think about it. Absolutely.
Yeah, well, I've seen this too many times,
Sure, so have I.
I talked to a law enforcement officer down in the mountains, Southwest Mountains here, back in the 90s when I was doing public programs down there, and he related a UFO experience to me, and it was all, well, golly, it was, it was 20 feet across, and it was 500 feet away, and it was going that way, and it went right over me. And, what he said, I'm sure sounded valid to him, but it was really useless information.
Yeah, but, the people that comment on these things, they're doing the best with what they have, and so
exactly.
And I know you
As
know
I
that.
said earlier.
I know you know that, and so
yeah,
that's how it works. Yeah, gosh, I guess I got a lot of dew out there on the lenses. At least it's a good thing that that's the all sky cam.
Wow.
But I just have to go wipe that off. I do have a dew heater on that. I don't know why it's doing that. That's okay. I was just trying to get us an image, but as you can see, we're just fine. We're getting very subtle details, so clearly we don't have an issue.
Are you still on the narrowband filters?
No, now we're on the other one. Went back to the wider narrowband filter 2.
Okay.
But let's move on off of here and go to another spot and look at something else. I actually had wanted to try and locate. I want to see if I can grab the pelican tonight. So, goodbye, Veil Nebula, for the evening. See what Tara says?
I do. Thank you, Tara.
Okay, let's see now. We're on Deneb, and then we're going away and moving to the Pelican Nebula here. And we have a bright star that should be visible. And it might be 56 Cygni down here, so if that's 56, that means that we're actually here. I have to move us over, but I'm going to... Okay, let me see here. Oh, it could be that too. Yeah, it could be that. Oh, I think it is that, actually. Okay, so what we want to do is... Let me just look at this again. I think we want to do... If that's what I think it is... Maybe not. All right, we'll take a chance. I'm just trying to... I'm just going to take a shot here. Do a 30-second shot. Just to check it out. And let's go make sure that our telescope is not having an issue with the pointing. It doesn't look like it is, but you never know. And you can see it here. Looks like it's pointing straight up. When we get rid of the dome and we just have a roll-off roof, that'll be so much better. Okay. 30-second shot here just to see. Oh yeah. So we can see parts of the Pelican Nebula here. And that's those two stars. I think I'm just getting placement, guys. Yeah, I think that's these guys. So, and this is the Pelican. So yeah, okay, we're kind of where we need to be, I believe. I'm gonna just move us down a little bit, though. So I'm going to bring those stars up a little bit more into the view. If I got it right, they should be able to come up to about here. Now let's see if that looks right. Yeah, see? Because we got that star and that star, which are these two over here, and this star down here, and that star over there. Okay, yeah, we are all set. We're dead center on right here. So we actually have this part of the Pelican. If we want to see the dark part, though, we have to kind of move over a little bit. So I gotta move us to more like this. So I gotta bring these stars in more. So that's what I'll do. That means we head east a little bit. Okay. So that puts us about here and about there. So that might be it. Let's see what we're looking here. Just getting the right placement. Let's give that a try. And we'll do this for a minute and a half at 25.6. Here we go. Okay, what do you got in the chat here?
Gas Mask is talking about the Fermi paradox. And the Drake equation.
Now, the Fermi paradox actually was attributed incorrectly to Enrico Fermi. He was actually having a discussion with Teller and several other scientists, and it wasn't actually Fermi that said, where are they, kind of a thing. It was actually the considered opinion of all of them talking about it. So, but it was attributed to Fermi. I guess they had to pick one. I'm just reading what he says.
I've seen a lot of so-called UFOs in 40 years under the night sky. I don't really find them all that interesting for the most part. I've never seen what I would call a flying saucer, with the possible exception of those two I mentioned tonight. I don't know what they were still, so I'll just call them UFOs.
You mean the one when you were inebriated?
Yeah, or 8 of them, or whatever
Okay.
there were. There were a bunch of them.
Look at this.
Hey, you got it.
That's beautiful. Okay, we're going to have some fun tonight with that guy. Okay.
Saw a bunch when I lived in Leadville. I mentioned before, there were a lot of reports of ball lightning up in the Central Rockies, and specifically around the Leadville area. There are a lot of mines up around Leadville. They're mostly all shut down now. There's still 1 or 2 operating, I think.
Isn't that the name? The name of the town is based on that?
Leadville?
Yeah.
Yeah, lead mines. It actually was first called Oro City, which was for the gold mines that were started there. But Leadville made its money on silver mines, and lead was kind of a byproduct of the silver mines. But they called it Leadville.
Yeah.
But there were a lot of reports of ball lightning. I may have seen it outside, but never underground. I know there were a lot of reports of people seeing ball lightning underground. And it was often attributed to, I'm sorry?
That's entirely possible, actually.
Yeah, they say it's due to piezoelectric effects from the compression of the rock strata in the mountains. I can't say. I saw a big red one once. To me, thinking about it later, it was moving very slowly. A friend and I were out at the telescope one night, and we saw this thing northeast of town, or northeast from our direction, looking over town. It was a big red light, and it was moving very slowly from east to west. And we must have watched that thing for half an hour. And it was a steady glow. It just very slowly drifted from east to west over town. And eventually, you could imagine it looked like it went behind the mountains over to the west of Leadville, kind of headed toward Aspen maybe, and disappeared. We must have watched it for half an hour. And I have no idea what it was.
Well, that couldn't have been like a ball lightning or anything, because ball lightning.
Was red.
Yeah. Well, besides that, ball lightning doesn't last that long.
Yep.
Naturally, you would think, okay, is that an astronomical object? Is it moving at speeds that are consistent with an astronomical object?
No, it wasn't.
It's going the right direction, east to west, but it wasn't moving in an arc. You don't know. So there's a lot of questions. So what could that have been?
First thing I thought of,
Balloon?
a balloon or a luminaria.
Luminaria.
Oh, you know, where people hang candles under bags and
Oh, you mean like a
they act like
Chinese
little hot air
lantern?
balloons. Yeah.
Yeah, well,
Luminaria is the Mexican version.
okay.
They're often lost for religious reasons.
Yeah.
Something of that sort, you know.
But a
The
half
color,
hour,
I don't know.
it,
Ultimately, I don't know what I saw.
that's actually consistent though with the timing. If you say you watch it for a half hour, that's not inconsistent. A half hour is about how long these can last. Typically, they actually last about 20 minutes. But I guess the fog of time could have expanded the time you thought you saw it. Maybe it was 20 minutes. Maybe it was less. I don't know.
We watched it for a long time.
I believe you. And if they're actually orangey red, they also can appear to flicker too. Depends how far away they are and so forth. But they can really appear to flicker too.
Yeah, and this was east to west, not west to east, so it wasn't a man-made object, or at least, something in orbit. As you would usually expect, things tend to move west to east.
Sure.
But I don't know what it was.
Yeah, because we launch in that direction because it's just the best way to launch.
Mm-hmm.
Can you excuse me for a minute now?
Absolutely.
I shall be right back, guys. I'll leave you with this picture. This is the Pelican Nebula here we're looking at. We're taking some images of this. And I'm going to just go... actually, before I leave, I'm going to go check my... I'm going to go out and wipe down that camera, okay?
Okay.
All right, I'll be right back.
Yeah, okay, lantern, I don't know. It's just idle speculation on my part. That was one of the things I thought of at the time. It was just a steady orange glow, kind of orange-red color, vaguely ball-shaped, and moving slowly from east to west. Watched it for half an hour. It was not an aircraft. And I don't know. It was interesting, whatever it was. I've caught myself in the old thing of, I was watching something from my driveway a few months ago, and I thought it was kind of jinking back and forth across the sky, in a zigzag pattern. But I realized pretty soon that was actually the muscles in my eyes, with no frame of reference around it. That was actually the muscles in my eyes making it look like it was jinking around. A lot of times you'll see people see Venus and they don't know what they're seeing, and they'll say it's a UFO, and they claim it's moving just because of muscle movements in their eyes. I don't mean to sound like a doubter. I just, I don't know. I've seen a lot of things 40 years doing this, and I can't point at anything really and say I saw a flying saucer as such, or Tic Tacs, or whatever. It was interesting, but there it is. I just let it stay at that, lay at that. Love to hear your stories, though. I think there's enough neat stuff to see in the regular sky. And I have seen some spectacular meteors in my time. I think last time I was on, I talked about the one we saw at my place with the drunk miners late one night while out at the telescope. They wanted to drive over to South Park and find it, and South Park must be, it's thousands of square miles. I mean, it's a huge place. It's Park County, Colorado, about an hour west of Colorado Springs. It's a large alpine valley north of the San Luis Valley. um, those miners would still be out there looking for it, unless they were properly equipped, perhaps. One guy did claim he saw it hit the ground that night. It was up around Evergreen, Colorado, which is in eastern Park County. He talked like he saw it closely. He said it was the size of a 5-gallon bucket. Now, just for finding a meteorite size of a 5-gallon bucket, that thing would be worth some money. And it was seen from surrounding states, not just Colorado. It came out of the south, and from our perspective in the Central Rockies, it was kind of headed in a northeasterly direction. People in other places, though, saw it moving other directions. They saw it moving straight north to south, or they saw it moving toward the northwest. People also saw it in New Mexico and Kansas and Wyoming, if I remember correctly. Mark's back.
Hey there. I was just listening to your story. I was enjoying that, so.
It was just that meteor story with the drunken miners.
Lead miners?
No, actually.
Bauxite?
Molybdenum.
Oh, molybdenum, okay.
We all worked at the Climax mine up at the top of Fremont Pass, east or northeast of Leadville.
Okay.
And it was a molybdenum mine.
Okay.
Molly be damned. Hey, I still have the t-shirt.
I bet you do. Molybdenum.
It says, I dig Molly. The Climax might have shut down by then, so the ones who were still mining were actually, I think, working at a coal mine someplace, Carbondale or somewhere.
Okay. Carbon.
Back in town visiting.
Carbon.
There you go.
Wow, that's really pretty. So we got some really pretty shots here.
Excuse me again for just a moment, please.
Oh, all right. Go ahead. So we're looking at a section of the North America Nebula. You can see the telescope is centered right about there. We're seeing these two stars right here and these two down here in the image. So there are those two stars there, and then there is this one, and there's one a little bit further to the right here that you can't see yet, but it's in there. So we actually have our stars there, so that's pretty good. And we move the image a little bit each time we take it, and the reason is because it allows us to average the noise we get on the image. We can average the noise better. I was going to say it's approaching 12:30 because my overhead light here is changing color to white, and then it's going to fade out. But that's what it does. So let's go change the color back. There we go. That's better. So guys, I want to thank you for joining me tonight. This is fun. We're actually we looked at the carbon stars to begin with, and then we're digging some nebula here that are really kind of fun to look at. We're doing 1.5-minute exposures here. Oh wait, let's check this out. Alright, we can't. I wiped it off, but it's not. Hey, welcome back, Daryl. Daryl's back.
Thank you.
Alright, let's do this. And let's do this stretch and see what we get.
Take your Windex with you?
Well, I actually did clean it off. I don't know why that's okay. There's a lot of stars out there, but as you can see, there's like a fog apparently on this. You can't see it there, but you can't see it there either. Hold on. Okay, so let's get the blue RAM. Let's cut that out, and now you can see it. You can see how there's a fog over the dome. There's a fog over this, and that may be on the inside, but it's supposed to be pretty clean in there, so it's not. All right, well, anyway, let's go look at our image.
It was a whopping 10% humidity here today.
A whopping 10%.
Yep.
Wow. This is interesting.
That's why they call it a high desert.
Yeah.
Got up in the 90s with 10% humidity, you know, like the old joke goes, it's a dry heat, you know.
Yeah. I know.
But anyway, we won't have any dew here tonight.
No. Okay. Let's move you guys back just a bit, or just pull you up a little bit. Okay, and take another shot. It's too bad that's got problems. I have to fix that now. I mean, it's not problems, it has to be cleaned thoroughly.
The guy I told you about here that runs an all-sky cam, former president of the astronomy club, he used a 10-inch Meade telescope too, I think, similar aperture to yours.
Okay.
And you know how some people are so particular about cleaning optics. He'd just go out there with a paper towel and a bottle of Windex and wipe off his corrector plate. He didn't seem to have a problem with it.
That makes us go, ah.
Yes, cleaning astronomy optics, objectives, and eyepieces and such.
That was your thing.
And then for all the years I worked on lasers, every time I had to touch an optic, my heart was in my mouth. Yeah. And, some people are just, shoot it with some Windex.
Yeah, I can see how people just sort of get like, well, what can it possibly do? They're not realizing they're taking all the high transmissivity coatings off when they do that, because the glass is coated with these coatings that help enhance the pass-through of light. And you can cripple by several percent, maybe 10 or 12%, you can cripple the ability of the light to transmit through the glass.
Oh, yeah.
And that's just not a good thing.
Well, laser optics are the same way, and we had lasers of our own, and we bought another company, and they brought all their lasers in with our operation, and I saw how these people cleaned their laser optics, and you would have been horrified. I mean, it was like Kleenex and a paper towel. And the optics were so scratched up and ruined, and the coating's coming off. I'm surprised the lasers even still worked, because these are coated optics too. And I started teaching the operators, a proper way to do it, and I think still a lot of them didn't get it. I typically cleaned the optics myself, except during busy season, and I was elsewhere and it needed to be done. Q-tips and alcohol, or actually we had some specialty cleaners that I found worked really well. But ultra careful handling and handle like eggs and all that stuff, and a lot of people just didn't get it. But some of our lasers had like 7 different optics in them, and each one was $300 some odd a piece. These were like the little small lenses in the CO2 lasers, but still they're several $100s a piece, and you're talking a few $1,000s worth of optics per laser.
Yeah.
I'll freely admit I've dropped a couple of them, and it's an ugly thing when they hit the concrete floor and break.
Yeah, you know what's funny is that the lenses used in some of these lasers, it's not like a regular piece of glass. A small glass lens may just chip when it hits the floor, but a laser optics, when they hit the floor, they shatter into a million pieces. Ask me how I know. I had my CO2 laser that we use in my shop here. I actually dropped that on the ground, and I literally watched it disintegrate into, I mean, it was a lens that had to be about, I'd say, 3/4 of an inch in diameter. I dropped it, and all of a sudden, I had what looked like a pile of salt on the ground.
Yep.
Shattered into millions of pieces. It's like, how does it do that? Well, the way it does that is related to how it was made to be able to pass through such high intensity radiation. It was actually brittle because of that. It's perfect because of that brittle nature. That's why it was able to pass through this light intensity without any problem. It's a very regimented crystalline structure. So, arg, that's what happened. No good.
We had some ND YAG lasers, and those things, the objective in those things must have been a 4-inch diameter lens. It was a galvo head YAG laser, you know, the whole head steered and wrote over a certain size table.
Okay.
Those things came in from this other company we bought, and good God, they were scratched. They had chips out of them, and they were still using them. And these optics are easily $1,500 a piece, if not more. It was comparable to a 4-inch telescope objective.
Wow. And
you're talking thousands of dollars per lens for those things. I'm amazed they even worked anymore.
Yeah, my focusing lens on the CO2 laser, I would have to take that out of the aluminum housing and clean it. And I started using a microfiber cloth because I was just getting lazy. The thing was very old. And finally, I couldn't get there was an area on the lens where the laser had actually taken particles in the air and fused them to the center of the lens because it was so hot.
Right.
And so I had to clean those off. And try as I might, I couldn't get those particles off. So I just said to myself, I gotta try some other stronger solvent. So I got acetone out of my closet.
Yep.
And I started using acetone on this. And you know what? It worked beautifully. It cleaned this sucker right up. It didn't do anything to the glass. It didn't hurt the glass. And I started using acetone from that point forward.
Yep. Oh, a lot of them, you read the manuals, RTFM, you know.
Yes.
Acetone is what they specify.
Yep. Acetone is the best thing.
Yep. The other thing I used to use, if they were just regular garden variety dirt, was, smoke, they'd fill up from the fumes. Dawn dish soap.
Oh.
Just a drop of Dawn dish soap, and preferably distilled water.
Yeah. I have a gallon of distilled water in there that I use just in case. I mean, I have a cooler for the laser cutter in there now, and that cooler uses a pump that circulates water through the laser at all times while it's on.
Right. Our YAGs were like that.
Yeah. This is just a CO2 laser, but it's a 60 watt, so, more than enough to go on a murder rampage in the post office, I guess. But only if you carry around a lot of equipment with you.
Right. We had 4 YAG lasers. They were 100 watt, if I remember right, and they were big old hulking things.
Yeah.
on very heavy tables, to damp vibration, and they were all water cooled, and they were a mess. Saw a couple of times where they sprang a leak inside the active laser head, and water just ruined everything. You're talking like $20,000 Q switches inside these things. And,
I don't know what a Q switch is actually, but
it's I've forgotten so much. It helps modulate the beam. I forget what it does.
Okay.
Except I know when 2 of these lasers got shipped to us, when they were torn down for shipment, some truck drivers did it, and they didn't drain anything. They loaded them in the back of a semi, 2 semis, and they got stranded in a blizzard in Kansas City, Missouri. And they froze solid. And nearly every piece of glass in both lasers shattered.
Wow.
Including a Q switch. Luckily, they had a spare among all their spare parts. That was a mess. And I had to put them all back together.
I was going to say, did you have to repair them?
Yes.
Ouch. Ouchie.
Nowadays, instead of these big old dinosaur YAG lasers, they sell little fiber lasers, which are, to look at, they're much more like a CO2 laser, I guess.
Okay.
But they do the same things that a YAG laser does, engraving metal, stuff like that.
Yeah. Yeah, YAGs are good for that.
They make a really neat noise, too.
Oh, yeah. The music, we call it the music.
Yeah, kind of a screaming noise.
Yeah.
If ever there was a laser, where Art Goldfinger would tell Mr. Bond, no, Mr. Bond, I expect you to die. This would be the perfect laser
That's
for
right.
it. They just go kind of a sound.
Yeah. Yeah, I know.
Yeah, kind of a screech.
Yeah. You expect me to talk? No, Mr. Bond. I expect you to die. That was a great scene.
Yeah.
Laser coming up between his legs. Yeah, okay, ain't gonna die very quick.
Yeah. Oh, that's what made me want a laser in the first place.
Watching James Bond.
Yep. Then I wound up having to take care of, I think it was 14 of them, and
wow.
The reality was not like expectation or the fantasy, caring for 14 lasers was a pain in the butt.
Yeah. That's too bad.
Yes, gas mask. They're using bright green lasers on the cops and the feds. And I can't say what I would do to those people if I was there.
Well,
they're trying to blind them is what they're doing, and they've been somewhat successful at it too, from what I've heard. They've had over 100 injuries from green lasers to the eyes of the law enforcement officers.
Well, I mean, all you have to do is put some silver two-way mylar on their riot shields, and those will get reflected right back in the eyes of the protesters,
Uh-huh.
So, hey there, Martian, how are you? Rascally Rabbit, how's it going? I missed you guys earlier. Sorry, didn't see you catch in there. See you come in. I apologize. So we're just doing some shots here of the Pelican Nebula inside the North American Nebula. We just did some other shots of the Witch's Broom in the Veil Nebula, which is an area within the Veil, which has got some beautiful wispy structure. And we also looked at some carbon stars. But you don't have to take my word for it. You can just look at all of our images, which are right here. This is the collection of that. Here is the Witch's Broom that we looked at. You can see this really, really fine filamentary structure here. It's really pretty. And we took a number of shots of that. We took shots of it in the very narrow band filter. Quite a lot, actually. And then let's see. We also took shots of Alberio. This is Alberio, a beautiful double star in Cygnus that forms the head of the swan. And we also did some beautiful, colorful blood red stars. These are called carbon stars. Probably my favorite type of star. We did a few of them. And this was just Deneb, I believe, so I was using it to test the quality of the night. So that's pretty neat. And now I'm noticing that we're also getting some traveling here on this, so it's like it's not quite right. So I'm going to make an adjustment.
Mark, Katie asks, what would cause a whistling sound on AM radio? High-pitched oscillating sound, hard to describe.
Oh gosh, it could be something in your own home. Typically a small motor will make that sinusoidal, your automobile engine would affect the AM radio dramatically and do that as well. Car radios were shielded from that stuff, that noise, but a regular transistor radio that you might carry with you would not be. And you would hear it, and it would actually make quite a racket, actually. Let me do this again now, because I don't want to lose my train of thought. Let's see. Okay, and let's try this.
Martian asks, so is the witch's broom an emission nebula?
It is. Yes, it is. It's actually emitting O3, doubly ionized oxygen. That's why it's blue shape. Blue color, I mean, sorry. Did I say blue shape? Oh man, I must be getting tired.
I think you did.
I did. Sorry, folks, I'm getting tired, that's all.
I'm getting tired too. I'm going to have to call it here in a little bit.
Yeah, okay.
Getting close to my bedtime.
Really? Well, it's 1:45 in the morning here, so.
Yeah, well, my body clock got so screwed up with the meteor showers. It happens every time. Trying to go to bed at 11 o'clock, 11:30 at the latest.
Yeah.
I'm old.
Yeah, right. Well, you know what? Once we open up SkyTour West and we have the Sonoran Desert Telescope going, right now it would be, at this time, it'd be 9:45 out there.
Yeah, I know.
We would only have been viewing for a half an hour so far. So I'm going to be shifting my sleep schedule so that I can still bring you guys the beauty of the night sky. But the Sonoran Desert sky is going to be, it's going to be like, I won't want to sleep. I won't want to sleep. I will not. I can promise you I won't want to sleep. Because the sky is so stunning out there.
Mm-hmm.
Yeah. Yes.
Oh, I used to be a night owl.
Yeah. Well, that's...
When you get to Arizona, you may have to keep Amanda with you, though. She's a night owl.
Well...
I just can't stay up late like I used to.
Oh, that's fine. We'll still do what we have to do. How we do here? Okay, stars are still wonky a little bit. I may be getting due on the Guider telescope, so I should probably call it a night as well, guys, because when I went out there, everything was wet. So there might be dew on there in the same way that there's dew on the all sky camera, and that would make it hard for the Guider to work. So that all said, guys, I want to thank you for coming out. Some reviews of the things we did tonight. As I said before, we did. This is the piece of the Pelican Nebula we did. This is the Witch's Broom, with a little bit of a refinement there for you. And we're going to be able to take that and really do some beautiful processing on it, I hope. We did narrowband processing on it here to actually show some of the beautiful detail in it. And then we did more of the Witch's Broom. We did more of it. And then, of course, without any further details, we did a central veil, a few of the central veil shots. And then we did, let's see, that's the central veil there. And this guy was Alberio. So we got some beautiful shots. And then the beautiful carbon stars. This was my favorite of the night, right here. This beautiful carbon star that was sitting next to another star out there. Absolutely stunning. I'll make all these available to you so you can see them up on the SkyTour LiveStream Facebook site. I typically wait a week and then put everything up at once, so I've got probably 10 to 15 photos to put up tomorrow or the day after. So, awesome.
Mark, thank you for having me on.
Well, and thank you all for indulging both Daryl and I. So you guys, you have a good night, and we will see you on the next SkyTour livestream, and we will catch you on the flip-flop. All right? So good night, everybody. This is the end of SkyTour for August 23rd, 2020. It was the 22nd when we started. Okay. See you all later.
Good night.